Alright guys, for this first one we have that hot air balloons are available in many sizes for different number of passengers. And here is an amazing picture telling us what a hot air balloon is, and that the following table shows the recommended minimum volume of a hot air balloon in cubic meters for a specific number of passengers. And they actually tell us that number of passengers is X and the recommended minimum volume is Y. So basically just passengers X, volume Y. So for example, if you have one passenger, the minimum volume is 1,000. If you have 5 passengers, the minimum volume is 2,500. All right, so for part A, we need to use the graphic display calculator to find the Pearson's product moment correlation coefficient R for these values. Now, most of the people reading this, first, they're going to start freaking out, and then they're going to say, what the heck even is this? And thirdly, they're going to say, I should have studied more. Well, good thing is you're watching this video, so this counts as studying more. Good thing it's happening now, not later. This word right here, Pearson's product moment correlation coefficient. The biggest idea you have to go for is when you read correlation. Okay, whenever you find yourself reading the word correlation, at the AISL level, you should immediately be thinking in line reg. Now, why do I introduce the idea this way? Because for each exercise, my recommendation is that you identify buzzwords like these key concepts, like Pearson's product moment correlation coefficient, and that leads you to think about line reg, okay? One thing is having line reg as a tool, and another thing is being able to identify when to use it, okay? You need both skills. So the moment you read the correlation thing, you should be thinking in line reg, and line reg is, not even I remember, but you can look for it quickly. It's stat and then calc, and here you have line reg. Okay, so basically what I'm trying to transmit to you is that to calculate Pearson's product moment correlation coefficient, you should immediately be thinking in line reg. Now, I don't expect you to memorize how line reg works, but I do expect you to know a correlation leads to line reg. Line reg, you find it here. And so you click on line reg and you realize, or you slowly start to notice what it asks for. So it asks for an X list and a Y list, both with L1, L2. Frequency list will not matter to us. Store reg EQ is if you want to store it in Y equals. And calculate is calculate. See, so list 1, list 2, we were going to go to stat again and then edit. And from here, we're going to plug in our numbers. Okay, so we can clear up top and then clear up top. List 1 is going to be your X and list 2 is going to be your Y. So if you plug everything as it corresponds, so 1, 2, 4, 5, 7, 15, and then 1,000, 1,350, 2,225, and etc. You can see that we basically, through these two lists, plugged in that table, okay? What do I suggest here? Make sure everything is aligned. So for example, this 1 goes with the 1,000, as we can see here, or this 5 goes with the 2,500, as we see here. Let me take a second to double check that everything's okay. As far as I can tell, it's fine. So now we go back to stat, go to calc, go to line reg. And as you can see, X list is L1, correct? I mean, as intended. So list 1 is X, list 2 is Y. We pop that calculate button, and bada 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 boom, we end up with these results here. Now, some of you at this step are seeing the famous R value, and some of you are not. In my case, I am not seeing my R value. See, and so I did this on purpose in case it happens to you. If you're not seeing your R value, you have to go to mode, this button here, mode. And although it looks scary, scroll down to stat diagnostics, and from off, switch it to on. And now when you calculate again, now you get that famous R value, okay? And so notice it's asking for R, not R squared. So for now, you are gonna ignore R squared. And so for part A, to show your work, I guess you can say like list 1 equals X, list 2 equals Y, and that you did line reg. Okay, this is just for showing your, the method points or whatever. And you ended up with r equals 0.99888. 99888. If you want to do significance figures, I guess you can count 1, 2, 3. Do you round it up or keep it the same? You round it up, so you can leave it as 0.999. And so over here, you can see that 3 significant figures, leave it at 0.999. All right, excellent. So that is for part A. For part BI, they tell us to find the equation of the regression line y on x for this data in the form of y equals ax plus b. And so from here for BI, okay, you can see that it says the equation of the regression line, which is actually what we just did with a line reg. See, line reg, regression line, it's pretty much synonyms, okay? So that's another sort of buzzword you can think about. If you talk about correlation, you're thinking about line reg. If you talk about a regression line, you're also talking about line reg, okay? It's the same idea in this case. So they tell you the line of y on x. And so the intuitive way to think about y on x, because I know that sounds kind of crazy, it's y depending on x. And y tends to be your dependent variable anyway, so this is perfect. Nothing weird in this case. So y on x is y depending on x. So list 1 will keep being x, list 2 will keep being y. And so from here, as you can see, when you do the line reg output, you have y equals ax plus b. And so it's literally all aligned for what they ask for. A is 340.379, B is 742.015. And so from here, just to be extremely organized, I'm going to say that A equals 340.37958, and that B equals 742.015. 742.015 70. And if you want to leave it in significant figures, we can say that this one up here is you count 1, 2, 3, round it up or keep it the same, you keep it the same. So you can leave A as 340, and we can also leave B as, do you round it up or keep it the same? You keep it the same, so B would be 742. And so using the format of y equals ax plus b, that means we end up with y equals 340x plus 742. And so that would be for part BI for finding the equation of the regression line. If we look at the answer key, that is actually exactly what you end up with. So 340x plus 742, 340x plus 742. And they tell us that the answer must be written as an equation. So that's a small detail that you must go for. How do you know it has to be written as an equation? Because they literally tell you, find the equation. Okay, so it's not enough to express A and B. You do have to write the equation. So that is for part BI. Now we can talk about part BII. So part BII says, state what the value of A means in the context of the question. And unfortunately, we don't have ChatGPT to answer this because you are in the middle of a test in theory, right? And so now you have to go into your brain and say, letters, what do letters mean? So state the value of A. What is A in this context? What is this letter doing? So A, hey, how you doing? A is the one that is next to X, okay? And so this right here, actually, the y equals ax plus b, in the world of math comes from, let me find this. Let me find it. I am not finding it. Sorry guys, technical problems. Wow, quite a few technical problems. Hold up here. Leaving in the video because it happens to anyone. Yeah, perfect. So here you have equations of a straight line, okay? So going all the way back probably to middle school, okay? A straight line can be expressed as any of these three sort of formats, okay? Quick tip, you usually start here, all right? Not for this exercise, but just, you usually start here and from here you go to everything else, okay? Why? Because this only needs the slope and a set of points and you're good to go. which is usually very easy to attain. Yeah. Right now we're talking about this format. Okay, and this format, which is the same as the y equals ax plus b, here they just put mx plus c. What you need to know is that this guy that's alone is going to be your y-intercept, and that this guy here, the m, is going to be your slope. And another word for slope is gradient. And so gradient, which is the same m from here, okay? We're just talking about slope, we're talking about rate of change. You might also hear it as rate of change, see? So m is your slope, c is your y-intercept, and so that is for m and c, ¿cierto? So y equals mx plus c. In this case, we're talking about ax plus b. And so a, which is the same as the m from earlier, okay? M is going to be your slope or rate of change or whatever, see? And so that is the first thing you can sort of mention for part BI. You can say that A, because of the format of the equation, because you identify that it's a straight line, that's like my whole point, because you identify it's a straight line, you can say that A is the slope. Now, of course, that's not good enough for AB, but maybe it's like 1 point. See, you're starting to make your argument. And so, or actually, now that I think about it, here's a key idea. They tell you in the context of the question, what the heck is A? So you can say, A is the slope. But in the context of the question, the slope being 340, what does it mean? So A is the slope, A is 340, which means, what does it mean? Well, let's remember, X was number of passengers. Y was recommended minimum volume. And so if X is 340, well, it's extremely similar to the jump we see from here to here. Give me a second. Yeah, perfect. And so basically what you can see, sort of, is that by adding +1 passenger from going from 1 to 2, your recommended minimum volume increases in just about 350, near 340. See? The reason it's not exactly the same is because this isn't either exactly linear. See, this is just like data, and this is a linear regression, so it's a very strong approximate. As you can see, the R being 0.999, it's a very strong approximate, but it's not perfect. So that's why it's +350, not +340. But coming back to the idea I'm trying to express is that the slope in this context means that for every additional passenger, you need roughly 340 more volume. And so A is the slope, A is 340, which means that for each additional person, we need around +400 volume. And honestly, this is good enough. If you want to get extremely fancy, you can say it in a more fancy way. You can mention the cubic meters. So we need around +400 meters cubed. Okay, if you want to get fancy, you can get fancy, but honestly, this is good enough. And if we look at the answer, there it says, so the recommended minimum volume of the hot air balloon increases by approximately 340 meters cubed for each additional passenger. So obviously, there's a lot of ways to express this. And as long as you nail the idea, that's what matters. See, and so nailing the idea is understanding that there's an increase. So that's like the idea of the slope that we put here. See, you need to mention that it's 340, which is the 340 we put here. And you need to mention that it's about volume, which is the volume we're talking about there. See, so that's pretty much what you need to express. See, so I think the bigger idea here, more than the context of the question, is understanding that you are talking about slope. It's understanding the idea of slope. All right. Yeah. That would be for part BI. And now part C, we need to use the regression equation from part BI, which is this guy here. Okay. To find the recommended minimum volume of a balloon for 10 passengers. So this is way easier than what we think. So the question is, recommended volume for 10 passengers. That's basically what's happening. using the equation from BI, which is y equals 340x plus 742. And so again, the big sort of challenge here is understanding how they want you to use this equation. Okay, so it is extremely important that you have very clear what is x, what is y. Earlier we mentioned that x is basically passengers and y is basically minimum volume. And so let's actually write that idea down here. So we have that x is passengers, y is minimum volume. And so if they're asking for recommended volume for 10 passengers, you can intuitively tell that they're giving you that passengers is going to be 10, so x equals 10, and you need to find the recommended volume. So you actually don't know what y is. And so this small step here, for some of us might be obvious, for some of us it might not, but it's important to have clear which variables they're talking about. What do you plug in? Do you plug in x equals 10 or do you plug in y equals 10? These are the small details and these are the small in between steps that are necessary to like make sure you get a good grade. See, so correct method would be taking a second to realize what is x, what is y, plug in x equals 10. Yeah. Así que you end up with y equals 340 times 10, which is the x we're plugging in, plus 742. So y equals 3,400 plus 742. And I'm a little bit of a boomer, so I'm going to do this with a calculator. Let's be honest, we all put in our calculators, even 1 plus 1 when we're doing a test. You can never be too sure. I've been there. 4,142, because we're talking about volume, you can leave it as meters cubed. And that is pretty much it. So use your regression equation from part BI to find the recommended minimum volume of a balloon for 10 passengers. This is probably good enough. This is showing your procedure, and I assume that's what the answer key has. So yeah, here we have that you need to show that you're plugging in x equals 10, so it's understanding which variable you're dealing with. And after that, finding the 4,150. And here, oh, that's interesting. Here they got 4,150, and we got 4,142. But I think that's because we used the significant values and they used the full equation. So as long as you're consistent with either using the full equation or using the significant values, you're going to be fine. See, so in this case, we got 4,142, which is a little bit different, but relax, no stress, no mess. That's because we used the significant values version while they used the full numbers version. Just so that everyone is relaxed about that, we can go ahead and plug in. We can try to plug in here. I don't have A and B here. But yeah, just so that everyone agrees. So we have 340.37958. So that is my A, ¿cierto? Times 10 plus our B, which is 742.01570. And there we get a little bit closer to the 4145. See? There it is actually, 4145. So, yeah, small detail worth mentioning. You still get full credit as long as you're consistent, which we were. So that is for number 1. And again, the biggest idea I can share with you, not just for this exercise, but for all exercises, is to have very clear the procedures, the tools, the formulas you need to try to follow. See, so the minute you read about correlation, the next minute you're entering your graphing calculator and using line reg. The minute you talk about regression line, again, you're using line reg. Okay, that is the sort of thing you need to really have ingrained in your mind to be able to face any exercise. The IB test, at least for AISL, it does have some creative hard parts, let's be honest. But the majority is just understanding the graphing calculator, the formula booklet, and just having these buzzwords leading you to procedures, leading you to equations, leading you to, what is it called? Leading you to graphing calculator functions and etc. All right, you guys, take it easy. That was for number 1, and I hope it helped. All right, guys, for number 2, we have that a car manufacturer collected data about preferred car color from drivers in various age groups. the results are presented in the following table. Okay, cool. So, just so that we're on the same page, this is saying that if you are between the ages of 18 and 25, but not including 25, okay? So including 18, but not 25, so you can be 24 years old and 364 days, okay? Apparently, for white, 12 people preferred that in this age group. 7 preferred black and 4 preferred silver, 17 red. And so the total of this row is 40. And if you count it, it should give 40, see? What about the total that preferred, I don't know, red? So the total that preferred red is 17 plus 12 plus 6, the 35 over here, see? And so essentially, one of the things we can point out immediately is that how much data did this guy collect? So this guy collected 150, okay? And if you split that into age groups, you can split it like this. So the 40, the 58, the 52. And if you want to look at it as just white, black, silver, and red, you can have these here. And so actually this plus this plus this plus this gives you the 150. This plus this plus this gives you the 150, see? And last but not least, if you want to jump into like how many people were, I don't know, above 45 and liked red, only 6. See, and so that is a little bit how you read this table. Okay, so very careful with the total columns. From here, part A is write down the value of B. Okay, so now that I already shared with you a little bit the intuition of how this table works, we can see that B is on this row, and it is also on this column. And so if we solve it looking at columns, well, the total of this column is 46. So you can say that 46 equals 7, which is this 7, plus B plus 18. And so that means that 46 equals 25 plus B. So that means that B equals, if you do minus 25 to both sides, you should end up with, wow, I cannot math today, 21. 21, should be 21, see? And if I solve it looking at the rows, it's a similar idea. You can express 58, which is the total, equals this 15, plus this B, plus this 10, plus this 12. This 10, this 12, see? So 58, we will have 15 plus 10 gives you 25, plus 12 plus B. So that means that 58 equals 37 plus B. And if you do minus 37 here, you end up with B equals, once again, ladies and gentlemen, bada bing, bada boom, 21. So that's 2 ways to find the value of B. There you go. B equals 21. And so from here, it gets a little bit more spooky. See? Now, before we jump into part B and C and etc., please notice the part A was just understanding this table. See? And so even if some of you might have read ahead and seen this nasty, nasty symbol that none of us likes, this chi-squared, ooh, spooky, null hypotheses, ooh, scary, alternative, ooh, spooky, keep in mind that part A had nothing to do with any of that. And so if you're trying to claw for points, don't skip any problem. In the sense that maybe you can do part A, maybe you can't do the rest the day of the test because you don't remember this or that, etc. It happens. But a good test taking strategy is answer what you can. And in this case, if you know nothing about chi-squared, you can answer part A. So not because an exercise says or has a part with chi-squared means that everything has to do with chi-squared. Okay, look at part A. Look at part D. Sometimes the last question is a context question, so it's easier to answer. Test taking strategy, see? Keep that in mind. Anyways, now we jump into the spooky part after solving for part A. So the spooky part says, the car manufacturer performs a chi-square test of independence at the 1% significance level to determine what? To determine if there is a significant evidence that different age groups have different car color preferences. So basically it's like, do boomers prefer red cars And do millennials and zoomers prefer white cars? That's like the question they're trying to answer. See? And so there's this thing called the chi-square test that helps you discover that. Okay, and it's a statistical test and this and that, and more than entering like the heart of how that works, I will enter into the heart of the procedure and what to do. See? So the first thing is, fortunately, they already defined the null and the alternative hypotheses. And here you can say that the null, which is the H0, so H0 is going to be null, H1 is going to be the alternative. So null says age and car color preference are independent, and the alternative is that age and car color preference are not independent. So what can we point out here? Usually, I wouldn't say always, but usually, or at least logically, you have that the alternative is like the opposite of the null. See? And so here you can see that the only difference is that the alternative says not. So that's the first thing I'm gonna sort of like point out. And the second thing is that the null is like, it's assuming no, it's like assuming the status quo. It's like assuming that there is no difference, there is no change. That's the null is usually no change. The alternative, because it's not the null, ends up being that there is change. And so yeah, that whatever. It's just logically how you can try to define the null on the alternative. But now again, let's jump into the procedure. Let's speed this up a little bit. So they tell us that the chi-squared critical value for this test is 16.81, and to first find the chi-squared test statistic. See? So this is the juicy part. When you read chi-squared test statistic, first, breathe in, breathe out, don't freak out. And secondly, go to your graphing calculator. See? What I need you to know is that it's somewhere in your calculator that you can try to solve this. It's not in the formula booklet, it's in your calculator. Yeah? And so what we can do, and this is what I expect you to do, it's not memorize where it is in the calculator, but it is to know and be aware that the tools are in your calculator. See? So we're gonna go to stat, and because it's a very statistical thing to do, test statistic, and we can go to this column here that says tests. Because hey, it's a chi-squared test. And eventually, after scrolling for long enough, here you end up with two. You end up with chi-squared test and chi-squared GOF. Okay? Now, again, I do not expect you to know by memory which one you use. So by now, you know it's your calculator, you found them, you found two of them. So you have chi-squared test and chi-squared GOF. And so, click on the first one and you can see that it has observed brackets A. And so this is the first idea we have to sort of go over. So you have brackets A, and that is like what you need to put it somehow, what you need to plug in. And meanwhile, if we go to test again and click on GOF, you can see that it asks for L1, L2. And so, so chi-squared is asking for the brackets A, and chi-squared GOF is asking for L1, L2. And so what is the difference here? GOF is going to be for, pretty obviously, lists. And chi-squared, like normal or without GOF, is going to be for what we call matrices. Now matrices, for us, we will just think about tables. And so, extremely obvious question, answer with confidence. Is this a table? Or is it many lists? I guess that's a tricky question to answer now that I think about it. But because you have something on your columns, which is preferred car color, and something on your rows, which is the age groups, it would have to be a matrix. It would have to be a table. Because you have the interpretation from columns and also the interpretation from rows. See? And so that is why we are talking about a chi-squared matrix or table. See, it's not four lists, one next to the other, because there's the interpretation of the rows. See? And so that is a little bit of intuition of why we're talking about the chi-squared. See? Now, from here, once you identify you're talking about a matrix, slash table, it's good to know that it's a matrix because here is hidden under math button, this matrix button. So if we go to matrix, you can see that we have the same big bracket letter. See? So from here, because we need to try to plug in, and actually let me remember how it showed up. So here you have observed and then you have expected. Okay, and this is a very specific thing I'm about to mention. For the chi-squared, the brackets, so A is observed, B is expected. Intuitively, I will tell you that plugging in observed, your calculator generates the expected. And this is for chi-squared matrices slash tables version. So this is for chi-squared, but for chi-squared Goff, L1 is observed, L2 is expected, and plugging in observed, your calculator doesn't generate the expected. Okay, so that is a lesson for another day, but I do think it's important to understand this subtle difference between chi-squared and chi-squared Goff. So chi-squared is for matrix, and then chi-squared Goff is for lists. And when you plug in the matrix, your calculator generates the expected one. So as long as you plug in observed, you're good to go. Bada bing, bada boom. But for the chi-squared Goff, if you ever need to use it, it doesn't generate the expected. So you have to calculate the expected. So you observed it just plugging in the data, and expected is like probabilities and stuff. See? So thankfully in this case we only have matrices. Así que we go back to matrix. We want to plug in for A, and if I click here actually, give me a second. Yeah, so if I click here, give me a second. Yeah, if I go to edit and I click on the first one because we want to edit it. Here, right now I have it as 3 by 3, but this is a little bit larger. See, it has 4 columns. So here you just gotta play around until you get the same thing. Some of you might put 4 here immediately and you can tell that, oof, that means I'm adding a 4th row. As you can, I gotta leave it as 3 times 4. And now I can go plugging in each value. Now some of you might be looking at this video and saying, man, I don't trust this guy talking about math online. I mean, what the hell? Where is the totals column? Where is the totals row? And this is where this boomer tells you you don't need to put the total columns or rows for this matrix. The calculator is going to calculate it for you. So that's another small but extremely relevant detail. You do not need to put the totals column or the totals row. Your calculator will calculate it for you because it is called a calculator. Anyways, from here, go ahead and plug in carefully. So you have 12, 7, 4, 17. And then I actually never checked if, yeah, B is 21. Nice. So we're correct there. B is 21. Then we plug in 15. B is 21. Silver is 10. Red is 12. And then we plug in this 12 here. You basically just copy your graph. your table. Better safe than sorry. Double check that everything's correct. And so doing a quick skim, I see that it is just fine. Yeah. So once you plugged in your matrix, and you can always check by, going back to matrix and pressing this first one, you can see that the observed values were just inputted. See? Now some of you might be thinking, well, what about my expected? Shouldn't this be updated? It's not updated until you run the function. And so if I run the function here now, so tests, pop this, observed is A, expected B, and I calculate, before analyzing the chi-squared and all that stuff, you can see that now, so now my matrix just got updated. It went from 3 times 3 to 3 times 4. And these are the, sorry, I'm trolling up there. These are the expected values, which do look a little bit different. See? That's just the calculator doing calculator stuff. Don't worry about it. All is good. Yeah. So now we will go back to chi-squared. Everything is correct, so we just calculate. And here now we have the famous chi-squared test statistic. And actually, let me write everything down. So we have that chi-squared gave us 18.331. I guess you can't put the full number with 3969. You also have your p-value, which is 0.00545. 0.0054552. 552. 481. And they also tell you that df equals 6, which is degrees of freedom. In this case, degrees of freedom will not matter for us, so I'm just not going to even write it down. See? If you want to leave both of these as significant values, the standard for AB is 3, so you will count 1, 2, 3, round it up or keep it the same. You keep it the same, so you can leave it as 18.3. And for the P, you can count 1, 2, 3 from here. Okay, and the reason you don't count the zeros is because starts with 0, followed by 0, followed by 0. So all these zeros, to put it in some intuitive way, don't really matter. Okay, it would matter if it was like, if you had a 1 here, then you would start counting from the 1. Okay, but because they're all zeros, you just count from the first number you counter that is not 0. So 1, 2, 3, round it up or keep it the same, you round it up. So significant values here would be 0.00546. Yeah, enough talking. That is for part B, finding the chi-squared statistic. Let's double check that it's fine. 18.3, 18.3, and then the long number 3313, 3313. Nice. So that's for part B. So notice that part B, we still don't know how to conclude the test. See? Maybe we don't even remember how to conclude the test. But you have the knowledge that you have chi-squared and that you have chi-squared Goff. And maybe you don't have this thing that I'm putting in a box right now memorized. And I, again, do not expect you to. But what I would expect you to know is that you have a version with matrix, you have a version with list. That is the minimum that I think you should know. And from there, you can just dig into your calculator until you find it. See? But that is the sort of intuitive concepts I need you to share. I need you to have. Your two main tools for when you're facing the chi-squared is the matrix version and the list version. And from there, you go slowly. Yeah, it's a matrix because it's not lists. It's a matrix because I have rows and columns. Bada bim, bada boom. See? So that is the approach we should sort of look for. So you plug everything in, you ended up with a chi-squared statistic. Again, we haven't even concluded, and you already have more than half of the points of the exercise. See? 3 out of 5, just like that. Yeah. Part C is the fun part. See? So you need to write down the conclusion of the test, which is a classic. They almost always ask for it. And in the context, give a reason for your answer. So here you can see you have 2 points, right? And so one of the points is the conclusion, and the second one is giving a reason. Why do I mention this? Because if you're clawing for points, you can try to conclude the test and not give a correct reason, and maybe you still get a point. As you can see here, for part C, one of them is the conclusion, which is writing something like this or that. And the other way, the other point is your reasoning point. See, so you have reasoning point here, which is your reason, quite literally. And then over there, you have the conclusion of the test. So I'm just saying, even if you don't know how to conclude, like the reasoning, you can just highball it, 1 in 2 chance that you get it right. Test taking strategies, that's all I'm saying. See, so you can always try to guess here if one of the points is just writing the conclusion to the test. You can even skip part A and part B and just try to guess the conclusion, and that can get you a point. See, so if you're clawing for points, it's a good test taking strategy. Let's come back to the exercise. How do you conclude this test? Now, how do I say this? There's 2 ways you can conclude, okay? So the first way you can conclude for part C is, so for concluding, you either compare your test statistic to your critical value, or you compare your p-value to your significance level. Now, what is the intuition of this? The intuition of this is that your test statistic with the critical value, look at it. It's 16.81 and it's 18.83. And so as you can tell, it's like literally a value. So here you compare values. You can think about like this thing that I'm putting in green is a little bit like you're comparing, like it's like a benchmark. Like, oh, if you cross this value, you need to be careful and this and that and whatever. See? So that is like a little bit what's happening when you compare test statistic to critical value. It's a benchmark. Like you cross this, you gotta be careful. See? Meanwhile, when we talk about p-value and significance level, it's a little bit different because here we have that the significance level is 1%. So, ojo, 1%, and p-value is a very, very small value, 0.005. So that's like 0.5%. And so for significance value and p-values, you are now talking more about probabilities. Okay, so you either look at it from the angle of benchmarks, like, hey, you cross this value, you're like in trouble or something's happening, or from the side of probabilities that, I was expecting like more than 1% and it ended up being less than 1%. See? So defining this through the benchmarks, you can say, or your reason. So yeah, let's start with the reason and then we reach the conclusion. Yeah, so the reason from the benchmarks is that 18.3 is less than 16.81. And this is important because you're basically saying that your chi-squared was less than your critical value. And so because the thing in green, the chi-squared, the critical value, your test statistic with the critical value is interpreted through benchmarks, you can say like, because the chi-squared passed my expected benchmark, there is a difference. So that's the main idea. Because my chi-squared value passed the... I just expressed this terribly. Hold up. I'm hella trolling right now. Boom. Okay. I'm leaving that in the video because it happens to anyone. 18 is indeed bigger than 16. Back to it. Because your chi-squared was bigger than your critical value, because your chi-squared passed the defined benchmark, something is going on, something is different. Your age and card color preference are not independent, and so your null is wrong. And so because chi-squared is bigger than critical value, intuitively it passed your benchmark, so H0 is wrong. That's basically one way you can try to define it. Because your test statistic is bigger than critical value, it's bigger than your benchmark, something is happening, it's out of the norm. That's like the intuition. It's out of the norm, it passed the benchmark, H0 has to be wrong. The other interpretation, as I was telling you, is through the sides of probability. And so through the sides of probability, it's a little bit different because you end up expressing that this, where do I have space? We're gonna do it here actually. So let me get rid of this guy there. So the way we can conclude it through the p-value and all that stuff, okay, is that you can say that 0.005 ended up being less than this 1%, which we can express as 0.01. And so, which makes sense. You have 0.010 is greater than 0.005. So in this case, what you actually end up sort of expressing is that your p-value was less than your significance level. And so this is a different way to think about it, but you reach the same conclusion. earlier we were talking about benchmark. So if you pass the benchmark, you're like way out, something is not normal, something is different, something is wrong. And meanwhile, through the p-values, you can say that you were expecting it to be like you were expecting it to be within this realm of possibilities, like 1% or more, and ended up being 1% or less. See, again, this is an extremely intuitive definition, not the formal one, but intuitively what I can tell you is that because we're talking about probabilities, the chance of seeing what I'm seeing is a lot less than what I was expecting. So if it's a lot less than what I was expecting, something is wrong, something is weird, something is not what I was expecting. See, and so here, because your p-value is way less than the significance level, so the probability of seeing what you're seeing is way less than what you expected, something is not normal, something is wrong. H0 once again will have to be wrong. See, so again, two ways to reach the same sort of conclusion. One of them is identifying that chi-squared is greater than your critical value, so it passed your expected benchmark. And the other way is identifying that your p-value is less than your significance level, so through the sides of probabilities, what you're seeing is way less likely than what you thought, and so something is different, something is not as expected, your H0 is wrong. That is the two ways to define this. Let me double check over here. Here you can say, claro, 18.3 is bigger than 16.81, which is what we try to express here. Or you can say that your p-value, the 0.005, is less than the 0.001, see, which is this guy there. So again, stick to one version. You either always try to define it through the probabilities through p-value, or you always try to define it through critical value and chi-squared, see? I tend to see that they give you both options at the AISL level. On some other levels, it's like they force you to solve through one of them, so they test you to know both. But I'm pretty sure for AISL, you can just always do p-value or always do chi-squared, and you're good to go. See, so whichever you preferred, stick to that one. And you can always define the same way. So as long as you know like these three things, you can even memorize it. You can always conclude correctly. See? And well, if the signs are flipped, so instead of aiming this way, it's aiming the other way, well then instead of H0 being wrong, H0 is correct, so you would like choose to accept it, see? And the way they define it is always kind of funny because you either, I mean, this is like statistically the norm, it's how they've always done it, so I suggest you do the same. You either express that you reject H0 or accept H1. So these are the same thing. So this is the same like sort of thing, okay? You either look at it from the side of H0, so reject or accept H0, or you look at it from the side of H1, reject or accept H1, see? And so I suggest you look at it from H0 because in my experience, it's more common, okay? To always think about it from the angle of H0. So you either always focus on saying reject or accept H0, or you always focus on saying accept or reject H1. See, that depends on you. I tend to see that people focus on H0, so I suggest the same for you. Ladies and gentlemen, that would have to be for number 2. A little bit challenging, not gonna lie. Statistics tends to be challenging, but the more important thing I can sort of mention is that what you need to bring to the table is your knowledge of the difference between chi-squared matrix and chi-squared list, specifically the expected thing that is very relevant, okay? And the other thing we can sort of mention is how to conclude. See, so as long as you memorize these 3 things and practice it a little bit, you should be good to go. Ladies and gentlemen, I hope it helped, and that would be for number 2. Ooh, cupcakes. Part 3, number 3, I mean. We have a bakery that sells boxes of cupcakes at the following prices. So they tell you that a small box containing 1 cupcake is $4.50. I don't know about you, but that's kind of expensive, isn't it? I don't know. Anyways, then you have inflation, you know. Then you have a medium box, which is 6 cupcakes, and it costs $23.50. And then you have a large box, which is 12 cupcakes, which is $44.75. Anyways, they tell you that in a particular week, the bakery sold 88 boxes containing a total of 383 cupcakes. The bakery collected $1,486 from cupcake sales for the week. and that the number of boxes of cupcakes sold during the week can be represented by this equation here. They tell you that, this is where it starts getting relevant, that X is for small. They also tell us that Y is for medium. I don't know why it's going gray, but whatever. And then you have that Z is for large. So X is small, Y is medium, Z is large. And for part A, you need to write down the equation in terms of X, Y, and Z to represent two things. One for the number of cupcakes and another for the money collected. Now, somehow the IB even made cupcakes turn into a nightmare. So that kind of sucks, but we will face this nightmare one thing at a time. So think about it this way. If you split this or try to organize this information, okay, here you have X for small box, Y for medium, Z for large, okay? And for X, you know there's one sort of piece of information which is for amount of cupcakes and another for how much it costs. And you can actually do the same for everything. So here is cost, and over here you also have contain. So basically what I'm trying to tell you, okay, is that you can organize X, Y, and Z into how much they contain, how much it costs, how much it contains, how much it costs, how much it contains, how much it costs. So for part AI, when they talk about number of cupcakes, we are not talking about how much they cost, but how many cupcakes they have, okay? Now, X, Y, and Z is each for boxes. So that is also important to understand that X, Y, and Z is each going to be for boxes, okay? So if for part AI, you need an equation for number of cupcakes. So part AI is equation for number of cupcakes. And they told you that the amount of cupcakes was 383. You can already know that it will be 383 equals something with X, Y, and Z. Ahora, because we were organizing X, Y, and Z into the category of how many cupcakes, you can think about it this way. 383 is the total amount of cupcakes. See? X is going to be a small box. But notice, 1X, or yeah, quite literally 1X. So one small box is one cupcake. See? So here we can just express X. For example, if you sold 383 small boxes, then X would equal 383. Makes sense. See? Ahora, if we're talking about a medium box, which has 6 cupcakes, here we need to put plus 6Y. Ahora, ¿por qué? What is happening here? See? Well, think about it this way. A medium box contains how many cupcakes? It contains 6, and 383 is the total amount of cupcakes. So one medium gives you 6 cupcakes. One medium gives you those 6 cupcakes. And so the last thing we're going to add here is plus the large box, which by now you should intuitively know what's going on. One large box gives 12. One large box gives 12. So that's why you do 12 times Z, because 12 is the amount of cupcakes, Z is the amount of large boxes, 6 is the amount of cupcakes, Y is the amount of medium boxes, and here I guess it would be 1 times X, 1 cupcake per small box. See? So, bada bam bada boom, X plus 6Y plus 12Z is going to equal our good old friend 383, which is exactly what we see over there. All right, coolio. So that would be for part A. We're going to leave our answer here in We're going to leave our answer. I don't know why my PDF is failing me. The color disappears, but that will be our answer. See? Let's put a star to remember. Yeah. So that is for part AI. Then you have part AI, which will be an equation for money collected. See? So again, we categorized X, Y, and Z first into cupcakes, now into just money. So now thinking about just money collected, one small box costs $4.50. one medium costs 23.50. And so now the logic, now that you got it, you can say, so one small box gave you 4.50. One medium gave you 23.50. And one large gives you 44.75. And how much did you collect during the week? During the week, you collected 1,486. Business is booming, baby. That's what I'm saying. So 1,486 will equal this equation here. See? So I'm going to highlight it again. Put a couple stars to remember that that's where it is. And that is exactly the equation for part 2. So 450x plus 350y plus 4475z. All right, cool. So that would be for part A. As you can see, it's just generating these equations, which I know is not the most intuitive thing in the world, but I do think it's important, or something that can help you, is that you realize that one equation is just for number of cupcakes. Okay, and it's super important, or what helped me back in the day, ¿cierto? Is to have very clear that this equation is only for number of cupcakes, because part of us wants to start doing stuff like one cupcake times 450 or 6 cupcakes times 2350, and you end up with a different sort of equation. You have to be very careful that here they're asking for only the number of cupcakes. This other equation is only for the money collected, and this equation is actually only for the number of boxes. And so notice you have one equation for boxes, another for number of cupcakes, and another for total money collected. And so the moment you realize that that is how you need to think about these equations, it's very categorical, only boxes, only cupcakes, only money collected, it becomes easier. See, so that is the sort of tip I can share with you when you face an exercise like this, which, by the way, I think it's getting more and more common. See? So this is the kind of exercise that I would assume enters your test. ¿Vale? All right, that is for part A. Now for part B, they tell us, hence, use your graphic display calculator to determine the number of medium boxes that were sold during the week. So basically, if you want to find medium boxes, you're asking for what the heck is Y. Ahora, basically what's happening is that you have 3 equations. Okay, so this is for part B. Yeah, you have x plus y plus z equals 88. You have x plus 6y plus 12z, I think it was, equals 383. Yeah, 383. And for this last one, my memory will fail, but it's 450x plus 23.50y plus 44.75z equals the big bank we made, which is 1,486. So think about it this way. You have 3 variables. You have x, you have y, you have z. And now if you try to solve for y from one of these, so for example, this first one, you end up with y equals 88 minus x minus z. And so this is a little bit of a problem because you can't solve for y just yet. You need to discover what x is, you need to discover what z is in order to get y. See? So I know this can be a little bit frustrating, but the intuition I can attempt to share with you, okay? The intuition I can attempt to share with you is that if you have 3 variables, but also 3 equations, you can solve this. So you have 3 equations, each with 3 variables. This is solvable, okay? And the tools you will be using is what we call substitution and elimination, okay? You can do these in any order as long as you're consistent and whatever you think is best, okay? In this case, I will be very instructive and show both elimination and substitution. What I usually recommend is that you always just go straight in with substitution, okay? I guess it does depend case to case, but for now I will start with elimination and then show how the other ones work, see? Now, oh, and by the way, if you end up Googling this, the concept you should be going for is, yeah, substitution, elimination, but also systems of equations. Okay, these are ways in which you solve systems of equations, which is either through substitution or elimination. So these three equations all start with three variables. See, and so the main idea of substitution and elimination is that you go from three variables to two to just one. Okay, that's the main goal, is that you decrease the amount of variables. Okay, so for elimination, you will basically be subtracting one equation over like another one. See, so let's say I take my second equation, and I highly suggest you write down somewhere like which is your second, which is your first, so you know where you're plugging in and don't plug into the same equation twice, because that is where mistakes happen. So here you end up with x plus 6y plus 12z equaling 383 minus your first equation. And so the first equation was x plus y plus c equals 88. And so the cool thing about elimination is that basically you will take one equation over another and put them on top of each other, and you will like do like a big subtraction. Okay, that is why it's elimination. So I'm going to put a big minus next to all of this. Okay, and what you basically end up with, okay, or the step in between, is that this guy here is going to turn into minus x minus y minus z equals negative 88. And so that means that this x goes away. Actually, let me rewrite it here. See, so you end up with x plus 6y plus 12z equals 383. And so basically now you can combine these two equations. After you do this minus here, you can combine, you can add them together, whatever. This x and this x both go away. And so here you actually end up with 0. The 6y minus y ends up as 5y. The 12z with the z ends up as 11z. And this 383 with this 88. I'm a little bit of a boomer, so I'm going to go ahead and use my calculator. Epa, so 383. Let me clear that. 383 minus 88. Eso es lo que te da el 295. So there you go with the 295. See, so basically you end up with 5y plus 11z equals 295. That's basically like what we tried to go for. See? Ahora, intuitively, all right, what I can try to share with you is that you passed from having x, y, and z in both of these equations to having only y and z. So there you can see how slowly you start chopping off variables and you go from one to less to etc. See? So 5y plus 11z equals 295. Because you want to get the value of y, a suggestion I have is that from here now I'm going to jump into substitution. See? And so, or actually, wait, give me a second. Give me a second to think about it. Yeah, so what we can try here, now that I thought about it for just a second, we can now again do elimination to again end up with only y and z. Okay, so now we can use maybe the first equation and the third one. Okay, so if I express the third one here, and I have 450x plus 23.50y plus the 44.75z equaling 1486. And then I put the first equation on the bottom. Here I have x plus y plus z equals 88. From here, if I attempt elimination here and I subtract immediately, ¿cierto? These guys nothing will eliminate yet. Okay, so what I can do from here is that instead of just subtracting the entire thing on the bottom, I can do minus 4.5. So that means I multiply everything by negative 4.5. So that means that what you end up with is 450x plus 23.50. So the equation on top remains exactly the same. Okay. And the equation on the bottom, because you multiplied by negative 0.4.5, ends up as negative 4.50x minus 4.50y minus 4.50z, equaling 88 times that negative 4.5, which gives you negative 396. Yeah, perfect. And so now we can sort of do like that, combine the two equations thing. This guy goes away with this guy, so again it ends up as 0. And here we end up with plus, pretty sure that's 19, but I don't want to mess it up. So 23.5 minus 4.5. If it's 19, so we end up with 19y plus whatever the heck that is. 40.25. And then this last thing over here is going to be 1,486 minus 396. 396. Yeah, so 1,090. And so from here you can see that I ended up with 19y plus 40.25z equals 1,090. Okay, so that was just two quick examples of elimination, and now basically you ended up with two equations. You ended up with this guy here and with this guy here. And so now I need these two equations to attempt to interact with each other, okay? And because you want to find the value of y, the idea is that you get rid of z. And so a way you can try to get rid of z from here, and now I'm going to jump into the substitution method. So substitution is basically like you get rid of a variable by plugging it in with some sort of value that is not itself, which sounds weird, but it'll get intuitive in a second. So ideally, from this equation, you plug in something for z, okay? And that means you only end up with y's, okay? Because right now, my two variables are y and z. So if I plug in z in terms of y, I end up with only y's, okay? So that means that this equation from up here, you can rewrite it as 11z equals 295 minus 5y. Intuitively, I'm trying to get z alone. So that means that z equals 295 divided by 11 minus 5 divided by 11y. And if I plug that over here, so this value of z right here, you end up with 19y plus 40.25 parentheses 295 divided 11 minus 5 divided 11 y equals 1,090. Now I know that some of you at this step are saying, dude, what the heck? What is happening? This is terrible. Get me out of this nightmare. But what I can point out is that, notice, your equations started with 3 variables. And through elimination, we ended up with equations that had only 2 variables. And through this last substitution step, we ended up with an equation that has only 1 variable. So yes, it looks nasty, but notice how through substitution and elimination, the core concept is that you go from 3 variables to 2 variables to 1 variable. And yes, this looks terrible, but we're going to reach y equals something from here. See? So using our trusty rusty calculator, we can do the 40.25 times this fraction. So to express a fraction, I'm going to do alpha y equals, press that first one, you end up with 295 divided by 11. So that gives you 1,000, that number. That's what it gives you. So you end up with 19y plus 1,079.431818. 431,818 minus, because we're distributing here, so we gotta multiply that one as well. You do the 40.25 25 times this 5 over 11, and it gives you that number. So 18.29 5454 5455 y equals 1,090. So from here you can attempt to combine like terms. So you can do this 19y minus this guy here. So you do 19 minus this guy here, which gives you that y equals, oh, sorry, pardon, not that y equals, but you end up with 0.70, 4, 5, 4, 5, 4, 5, 5, 4, 5, y. And then you want to pass this 1079 over here, subtracting, ¿cierto? So you do 1090 minus this number, which gives you 10.568, 182, 568, 182. And from here to get y alone, you divide both sides by this nasty number. 4, 4, 5, 4, 5, 4, 5. Divide both sides by the same number. So y ends up being this guy divided by that guy, which gives us that y equals basically 15. We can just leave it as 15. See? So all of that just to reach that y equals 15, y equals 15. 15 boxes. And if you were in a different exercise where they tell you to find the value of x, y, and z, in this case it was only asking for medium boxes, well, on this last step for system equations, where you reach a value of y equals 15, you can just plug this in almost anywhere to get everything else. So if you plug in y equals 15, I don't know, here, you're going to get something for z. And so z is going to be 295 divided by 11 minus 5 divided by 11 times 15. And so z should be 20, which it is. So that gives you z equals 20. And then to find x, well, you have maybe this equation. So x plus y plus z equals 88. So that means that you have x plus 15 plus 20 equals 88. So like basically x plus 35 equals 88. So x ends up being, I'm too old for this. Let me use my calculator. Thank you. X equals 53. Yeah. So that is like a last sort of step for finding all the sort of different variables. In case you have a similar exercise where you need to find x, y, and z, then yeah, you can do it like that. See? All right, you guys, that is how we solved it using elimination and substitution. The tough part here of using elimination is that we had to do it twice in order to get two equations that had only y and z, so that they were like more aligned. See? Usually what I do in my videos is that I use just a substitution. So substitution, first one into second, second into third, bada bing, bada boom, you're done. But really, in this case, I want to show both tools because I think everyone should try to get comfortable with what they prefer. See? Así que whether it's substitution or elimination, I suggest you master it and always solve it in the same way. Because this type of exercise does repeat a lot. I have seen it with more frequency. The IB is digging this. And so you should get into it too. See? All right, enough talking. That is cupcakes. I hope we made cupcakes emotional again, or at least less nightmarish. All right, you guys, take it easy. Have a cupcake. Have a nice day. All right, you guys, we have that for number 4. A swimming pool has a shallow end where the depth of the water is 1.2 meters, which is these 1.2 meters, and the deep end where the depth of the water is 2.0 meters, which is that over there. A cross-section of the water in the swimming pool with additional dimensions is shown in the diagram. So every time they say cross-section, it's like not a square, not a rectangle, but something a little bit more like this. So maybe it's like a rectangle plus a triangle, stuff like that is what they mean by a cross-section. So a safety regulation states that the gradient, first big important word, of the sloped floor, so this guy here, blah, 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 as shown in the cross-section, must not be greater than 1/3. And so for part A, we need to show that the swimming pool satisfies the safety regulation. Now, here's a couple of things we can mention. The first thing we can mention, okay, is that because the exercise says show that, then this is true. Okay, if it says show that, it means that the gradient is not great, blah, blah, blah. The gradient of slope 4 is not greater than 1/3. So show that, it's a little bit like prove, you know, that the pool does follow the safety regulation. So if part B needs something from part A, and you have something that says show that, you can take this statement as true from part A. The other reason it's useful to identify the show that in a question, okay, is that it means you can also skip it, because part A is like true and you can solve part B, or you can skip ahead. You can skip the show that exercises and just take part A as like true, you know, that's what I mean. So in this case, it's not particularly useful, but whenever you see the words show that, keep that tool in mind. Enough blah blah, let's jump into the actual exercise. The first thing we need to establish is what the heck is gradient. Okay, gradient, a similar word you might have heard for it, is also slope. And gradient is actually in your formula booklet. So remember guys, the day of the test you're walking in with a couple of things. You're walking in with a pen, with a pencil, with a calculator, with an eraser, 2 years of experience of this thing called IB, 2 hours of sleep, and the formula booklet. So the formula booklet, it's very important that you get used to it, you get to know it, and identify all these key concepts. And so the moment you're reading gradient, in your brain, it should be clicking, gradient, that shows up in the formula booklet. And you go to the gradient formula and you work from there. That procedure that I'm explaining is extremely useful. The formula booklet, you have to get to know it, you have to learn to love it, and you have to know what's in it. A very common trap is that people say, I'm going to walk into the test with a formula booklet, so I don't have to memorize it. And I say, yep, you don't have to memorize it, you're correct, but you do have to know what's inside of it, okay? Don't assume that because you have it, you know it. Okay, practice with it, learn with it, identify these keywords. Gradient appears in formula booklet. You go to the formula booklet, you encounter this, okay? So what are we looking at here? This gradient formula, the m equals y2 minus y1, x2 minus x1, it's only talking about sets of points, okay? So that is all you have to plug in. If you plug in 2 sets of points, you're good to go. But the bigger idea I want to explain here is that conceptually, okay, gradient, as you can see up top, you have the y values, and on the bottom you have x values. And so another way you can think about it intuitively is that your gradient or your slope is going to be your change. This triangle is for change. Okay, so it's going to be your change in your vertical divided in your change of your horizontal values. And so slope will always be that, just change in vertical divided by change in horizontal. Okay, another way you might have heard it, at least this is how I heard it back in my day, was rise over run. So it's your values that are rising, so your vertical values, divided by the values that are running, which would be horizontal values, okay? So anyways, the heart of gradient or the heart of slope is the idea that you're talking about vertical divided by horizontal. Vertical change divided by horizontal change. That is basically slope, that is basically gradient. And what a lot of people encounter in this exercise is that gradient, or the gradient formula, the way they give it to you is y2 minus y1, x2 minus x1, so it's sets of points. But if I go over here and ask you, what sets of points do you see here? Well, I don't see any. And so a lot of people from here are like, oh, GG, well played, on to the next. However, this mini step that I'm showing here, the concept, the intuition that gradient or slope is change in vertical divided by change in horizontal, means that you don't necessarily need to have these sets of points. If you can identify the change in vertical and the change in horizontal without sets of points, then you're finding the slope, you're finding the gradient. If you have sets of points, you plug in and forget about it. But in this case, we have to stick to the intuition, to the heart of the concept, which is vertical divided by horizontal. And so what the heck is vertical divided by horizontal for this sloped floor? Well, let's first talk about, or actually, just for part A, we're going to be talking that we need to find the vertical change divided by the horizontal change. So for this sloped floor from this orange point to here, what are my vertical values? By how much am I changing? Well, they told you earlier that all of this is 2 meters and that this guy here is 1.2. So basically, and stick with me here, basically, you can have this green line, which I will replicate here. So this green line is the 2 meters, right? And then you have this line in pink, which is 1.2, which would go like, I don't know, from here to just around here. So if you do the green minus the pink, you have the remaining, which we will be putting in dark red, or just red, I mean, which would be this height here. So red plus pink gives you green. Red plus pink gives you green. And so 1.2 plus how much gives you 2. 1.2 plus 0.8 gives you 2. So this height here is 0.8, which just comes from 2 minus 1.2. And then we can do a similar sort of exercise for the horizontal value, okay? And so for the horizontal value, you have that this entire line here is 7.5. And what you know about this 7.5 is that from here to here, it's 3.0 because of this guy. And you also know that from here to here, it's 1.8 because of this guy. And so what's remaining is, well, literally what's remaining. So you can do, I don't know, we're going to put this as x, okay? So you can have that 3.0 plus x plus 1.8 has to equal 7.5. And so with some quick math, you end up with 4.8 plus x equals 7.5. And so x has to equal, how much is that? 2.7, if I'm not mistaken. But let's double check. There's no reason not to. Let's be honest, we all do this. Even 1 plus what we put in the calculator the day of the test. Yeah, x equals 2.7. Thank you very much. And so from here, we can see that the horizontal value for this triangle is 2.7. See? And so sticking to the idea that gradient is change in vertical divided by change in horizontal, well, this sloped floor, this thing in orange, vertically, it has that 0.8. And horizontally, it has that 2.7. And this, ladies and gentlemen, is literally the gradient of the sloped floor. And so, popping all of this into our calculator, we can do alpha y equals, and then press this first one to pop a fraction. Now just one additional way to put it into the calculator, you end up with 0.29629. 0.29629. If you want to do significant figures, you can count 1, 2, 3. Do you round up or keep it the same? You keep it the same, so you can leave it as 0.296. And so, is 0.296 greater than 1/3? Well, this is in decimal. This is in fraction. So let's put this as a decimal. See? How do you put it as decimal? You just do 1 divided by 3. As a decimal, it's 0.333. And so, because it says show that, you do have to give a reason. Okay? And so, part of it was finding the slope. So the slope is 0.296, right? So that is one of the points out of 2. But in order to get full credit, because it says show that, you have to give a reason. So basically, from here, you simply say that 0.296 is less than 0.33. And here you can put like a little bit of text if you want to be like really, really correct. You can say the gradient of the sloped floor is not greater than 1/3, or not greater than the regulation, whatever, blah, blah, blah. See? And as we can see over here, well, there is a gradient, 0.8 divided by 2.7, 0.8 divided by 2.7, and then the reason. So notice, 1 point for giving the answer, finding the slope, another reason for giving a reason, okay? And then putting a little bit of text is never bad. Yeah, that is for part A. Part B is a little bit juicier and also pretty hard, I'll be honest. It's harder to think about. That's the challenge here. For part B, they tell us that the time to fill the pool with water is inversely proportional, which is already a scary term, to the water flow rate in liters per minute of the hose being used. A hose with a water flow rate of 300 liters per minute will completely fill this pool from empty in 4.5 hours if the hose is run continuously. So for part B, you need to determine the time it takes to completely fill the pool from empty using a hose run continuously with a water flow rate of 170 liters per minute. So obviously this is so much information. So let's try to make it a little bit more friendly. The first thing we have to attempt to realize is that there's two main variables here, and take a second to try to identify which are those two main variables. The first one is time. And so there it talks about time. Here it also talks about time. Here you need to find the time, so determine time. And the other concept we have is water flow rate. Water flow rate here is 300. And then water flow rate is 170. And so now that we took a second to read it more closely and thinking in these key sort of variables, what you identify is that in one scenario, the one they put up here, okay, is that with I'm going to put just W for water. So water 300 also means the time is 4.5. And below for part B, they're saying basically that for water 170, what is the time? Because the paragraph up top is telling you, hey, there's a case where with a water flow rate of 300 liters per minute, we fill the pool from empty to full in 4.5. So that is here. 300 for water flow rate, we fill it up in 4.5 hours. And then down below, what they're asking for is, what if my water flow rate is 170? And how much do I fill up the tank or the pool or whatever? See? And so that is the second bit of information. There's two main approaches to this, okay? One of them is using the fact that they tell you the inversely proportional thing. The inversely proportional thing, if I were to put it in more intuitive terms, let's focus on just this first sentence. So focus here for the inversely proportional. So right there, they're telling you the time to fill the water, to fill the water, the time to fill the pool with water is inversely proportional to the water flow rate. And so the time equals, basically, time equals water flow rate inversely proportional. So time equals the water flow rate being inversely proportional. Now, what the heck is inversely proportional? Inversely, the intuition I need you to go for, a little bit like inverse, it's that you're going to flip it. Flip it. That is basically the intuition I need you to have. So time can be written as your water flow rate, but not equals W, but rather 1 divided by W. And so you can also rewrite this as, if you put W to the other side, you end up with TW equals 1. And then you want to get W alone, you divide by T. So W equals 1 divided by T. And so you can see from here, T equals 1 divided W, or W equals 1 divided T. Okay, it's the same thing. And so if you looked at the answer key, that is actually one of the things that shows up. Okay? And one way you can attempt to solve this is through that inversely proportional thing. And here it is implied to have a K value going around, because it's not that W equals 1 divided by T, like literally, like yes, it's inversely proportional. But if you plug in your values, for example, T is 4.5 and W is 300, 4.5 does not equal 1 divided by 300. Like it just doesn't, right? And so that is why the K value appears, or actually more conceptually, the way I like to think about it, like this has to be multiplied by some sort of factor in order to make sense. So you put times K on the other side and you solve from there. So that is one approach you can take using the inversely proportional. Personally, I don't like it, and there's a far more intuitive way to face this exercise. I mention it because it's important to have more tools in your toolkit to know that there's more than one way to face an exercise. But I don't suggest that version. The version I suggest is focused on these two pieces of information that we identified. So because all of this is proportional. All right, so from here, now that we established these two main ideas, which is these 2 points here, followed by the fact that you can rewrite t equals 1 divided by w, or w equals 1 divided by t, okay? What you can now attempt to express using this as an idea, okay, is that technically, because everything is proportional but also inversely proportional, and knowing that basically you have w divided by 1 equals 1 divided by t, you can express w1 is going to equal, ¿cierto? Or actually w1 divided by w2 is going to equal t2 divided by t1. And this is because we're talking about inversely proportional things. Now I know this is a little bit crazy, but stick with me here. Basically, this right there, which is w divided by 1 equals 1 divided by t, is this with this. And if you rewrite that to flip it, okay, so if you flip that, you end up with 1 divided w equals t divided by 1, which is actually a little bit what happens here. See? Just keeping w on the left, so that would be this w with this t. All right? Essentially, we are combining two ideas. You are combining the inversely proportional stuff, which is the stuff we did here, okay, alongside the data you found for the two scenarios. So the first scenario was w equals 300, time equals 4.5, and then w equals 170 and time equals, you know, what you have to determine. So now that you establish this formula here, everything becomes much more easier. So you plug in w1 as this 300, w2 will be that 170, time 2 is going to be this t, so careful with that, and time 1 is going to be 4.5. So again, I feel like this kind of exercise is not easy because it talks about inverse proportions and you have to combine these ideas with this, which is definitely not friendly. But at least the intuition I can share is that if you establish this equation, everything just flows. See? The other good thing is that although it's a hard exercise, it is fairly common to have it asked in an IB test. See, I feel like at least once per test they might pop. I'm not always, but it's a fairly good chance they're going to pop something with inverse proportions. So you can also attempt to memorize this and just go from there. Anyways, when you have two fractions equaling each other, you can cross multiply as I put this x here. So basically you do 300 times 4.5 equals the 170 times t. So that means that t equals 300 times 4.5 divided by 170. So all of that in your calculator gives you t equals 7.9411. 7.9411. If you think about significant figures, you can count 1, 2, 3. They round it up or keep the same. You keep it the same, so you can leave it as 7.94. Our units are hours. And if we check over here, you can see that this proportion, which we wrote earlier, ends up with you expressing this, which is one of the answer points. And then here you have the time, the 7.94. There's the 7.94. And the last point was actually establishing the inverse proportionality here, okay? Which we did establish with these points here. And so everything is implied. That would be for part B. Again, not an easy exercise. And the procedure I would suggest is that the moment you see inverse proportion, we'll first try to get as much information as possible, organize matching the W's with the T's. And then if it says inverse proportional, it would be something like this. If it's only proportional, then it would be without flipping, see? But that's the tough part, you know, combining this idea with this stuff here. But everything is possible. I hope the colors helped a little bit, pink with pink, blue with blue. And I hope it helped. Take it easy. All right, you guys, number 5 is kind of wild because I don't know who can see this in time and calculate everything. But hey, the IB is the IB. So someone out there saw a dolphin that jumps out of the water, which is already kind of amazing, and that the path of the jump can be modeled by a quadratic function. And so already they are making dolphins not as exciting as before. Dolphins are now a quadratic function. Did we create math or did we discover it? I don't know. Anyways, a quadratic function is this guy here. You might have also heard of it as a parabola. And so they tell you that d is the horizontal distance from the point where the dolphin leaves the water, and h is the height of the dolphin above the surface of the water, which makes sense. Here's d, here's h. It's the same as telling you that your x value is going to be distance and that your y value is going to be height. No difference than that. See? So on a particular jump, the dolphin, they don't even put a name to it. We're going to call him Luigi. So Luigi the dolphin first reaches a height of 5.1 meters above the surface of the water when the horizontal distance is 3 meters, and again when the horizontal distance is 8.5 meters. And so from part A, you need to write down the equation of the axis of symmetry of the quadratic function. Yeah, there's a lot of stuff going on. So our good old friend Luigi out here jumping in the water gave us a very hard problem. Let's first understand what they're telling us here. So they tell you, Luigi the dolphin reaches a height of 5.1. So reaches a height of 5.1 when? When the horizontal distance is 3. And again, this is a huge word, and again, when the horizontal distance is 8.5. And so the mere fact that they told you the word again is a huge hint that it is not at the maximum, okay? Because it says again, it means that, for example, if the height is 5.1 here, so that means if I draw this line of 5.1 with my amazing art skills, you see that it touches there and it also touches there. And so this is what Luigi the dolphin is trying to tell you. It's trying to tell you that this height of 5.1 meters happens here at 3 and again at 8.5. That is what they're trying to tell you. And through all of this, you should be able to write down the equation of the axis of symmetry. And so that is already another big word entering our brains. Axis of symmetry, quadratic function. Guys, when you have a quadratic function, there's a couple key concepts you have to know. So let's say your quadratic looks like this, okay? And here's my x and here's my y. Let's actually rewrite that quickly. Something like this. Yeah, so your quadratic function, the key things you have to know. Actually, let me rewrite it again. Sorry. Let's rewrite it like this. Boom. That's a little more like it. Yeah. So if your quadratic function looks like this, the key concepts you have to know are that these, in red, are your x-intercepts, which might also be called zeros. So it's wherever your function, your parabola, touches the x-intercept. This guy here, of course, is going to be what we call the y-intercept. So it's wherever it touches the y-axis, okay? That is only once. For the x-intercept, it can be twice, it can be once, it can also be 0 times, but usually it's going to be 2 times. The other thing we can point out is this guy here, which is the vertex, which is like the min or max of your function. See, so in this case, it's a maximum because it's at the tippy top, but if your parabola looked like this, then this vertex would be a minimum, okay? So small detail. And why do I talk about this? Because the other thing you have to know is that you have this thing called the axis of symmetry. So this line here is your axis of symmetry. So symmetry, simetria. Essentially, the cool thing about the axis of symmetry, or the cool thing about a parabola, is that it's like a mirror on both ends. See? Why is it a mirror? Because if, I'm going to make these numbers up, yeah? But if your axis of symmetry is right on, I don't know, x equals 3, and you know that this guy here is x equals -1, well, from here to here, you moved how much? Well, from x equals 3 to x equals minus 1, it's a total of 4. So if from here to here it's 4, then to the other 0, it also has to be 4 because of the axis of symmetry. Because this parabola is a mirror, because the distance to one end from the middle to the left is the same from the middle to the right. And so that means that 3 plus 4 gives you that this other 0 has to be 7. And as you can see, the other big important thing about the axis of symmetry is that this axis of symmetry is also right on the vertex. And so although we still don't know the y value for the vertex, you know that the x value of the vertex is 3. And so that is why the axis of symmetry can be so important. And so up here, when they tell you this random piece of information that Luigi the dolphin reaches a height of 5.1, once on 3 meters and again on 8.5, this can actually somehow, I'm not sure how yet, can help you find the equation of the axis of symmetry. Now, what is the equation of the axis of symmetry? Well, equation, you should be thinking formula booklet. We go to the formula booklet, and actually right here, you can see that the axis of symmetry of the graph of a quadratic function. So whenever you have a quadratic function, which is what I expressed here, so whenever you have a parabola, you can see that the axis of symmetry will be x equals negative b divided by 2a. So x equals negative b divided by 2a. But the more interesting part, which is more conceptual, which actually has to do with what we're talking about down here, is that because the axis of symmetry is always right down the middle, you can actually unlock the axis of symmetry with any 2 points that are on the same line. So using these 2 zeros, for example, if you try to find the middle between the negative 1 and the 7, you're going to end up with 3. But if you also try to do the middle between this and this guy, you're again going to end up here. And so the middle of, I don't know, this guy and this guy will always be the axis of symmetry. So the concept I'm trying to share with you here is that on the same line, so this or this or that or this, the middle of all of that will always be the axis of symmetry. And so up here, when they gave us this piece of information that Luigi the dolphin has 3 meters and 9.5 meters for reaching the 5.1, well, the middle between these two will always be right on the axis of symmetry. The middle of those two. So what is the middle between 3 and 8.5? The middle between 3 and 8.5 for part A, we can say that 3 plus 8.5 divided by 2 is going to be the middle between both, which actually gives you 3 plus 8.5 divided by 2 gives you that 5.75. And so the equation for the axis of symmetry is going to be right on that 5.75. So in this case, unfortunately, the equation of x equals negative b divided by 2a doesn't help much because they still don't give me points. They still don't give me anything to discover what b is or what a is. So that means we have to boil down to the intuition of these concepts. And the intuition of these concepts is that on the same line, you can always find the axis of symmetry by just finding the middle of them, because the middle will always be, well, the middle, the axis of symmetry. Yeah, enough blah blah. That is for part A. For part B, they tell us that the quadratic function that models Luigi the dolphin's jump is this guy here. So negative 0.2 d squared plus bd, and they tell you that d has to be positive. Thank you very much. B is a constant, and to calculate the value of b. Now, a common thing in IB exams is that this doesn't always happen, but it can be a big hint that whatever you did in part A, you need it for part B. This is not always true, but it's good to be on the lookout for scenarios like that. And so part B asks you to calculate the value of B. And in part A, you played all out with the axis of symmetry. Now the equation for axis of symmetry is x equals negative b divided by 2a. And if we need to find b, well, do you have this one? You do, it's right here, because this is for the equation of axis of symmetry. And do you have this one? Well, now you do, it's right there. Because remember that your standard, you know, like your factory settings are f of x equals ax squared plus bx plus c. And so a is whatever's next to x squared. And your squared here, what's next to it is negative 0.2. So basically I'm saying that the axis of symmetry is 5.75, which is this x value, ¿cierto? Following the equation, and that a is negative 0.2. So if you plug all of that here for part B, you end up with 5.75 equals negative b divided by 2 times negative 0.2. So what I would do from here is first get rid of the negatives, because if there's one up top and on the bottom, they both, cancel each other out. So you end up with b divided by 2 times 0.2. Okay? And so that means that 5.75 is going to equal b divided by 2 times 0.2, which looks like that, so 0.4. And so that means that b has to be b has to be 5.75 times the 0.4. So 5.75 times this 0.4, bada bing bada boom, 2.3. Así que b is 2.3. There you go. Part of the method point was actually using the axis of symmetry formula, using our 5.75. Yeah, that would be for part B. Then for part C, they tell you to find the horizontal distance when the dolphin re-enters the water. So as you can see, re-entering the water is this guy there. And by now, it should be ringing a bell, because what I showed you earlier from here is that this point in red is wherever it touches the x-axis. So it's your zeros. So really, and the IB loves to do this, they throw you a question within the context of the question. So they're saying, hey, when does Luigi the dolphin re-enter the water? But this re-enters the water is really just asking for the x-intercepts. So the challenge here is finding the x-intercepts of our function. Now, our function as of now is this guy here, and we just discovered what b is. So you can rewrite it for part C as h of d has to equal this negative 0.2 d squared plus bd. So b is 2.3 and d is d. Yeah. So how the heck do you find the zeros from here? There's two main approaches. I'm going to give you the one that always works. Okay? So it might take a little longer, but it does always work. The first thing you're going to do is establish that an x-intercept, a 0, what it will always have, and it's a little bit like intuitively might be obvious, but we have to say it out loud. An x-intercept will always have 0 for its y value. And so because it always has 0 for its y value, well, that's your first step. Your y value, which is this entire guy, is going to pass to be 0. So 0 equals negative 0.2 d squared plus 2.3d. Now conceptually, on this step, what you're asking your function is, when my y is 0, what is my x? Which is the same as trying to discover your x-intercepts. Okay, that is conceptually what you're doing on that step. Now from here, how the heck do you solve it? Well, one of the formulas you can do, which I don't know if it's in your formula booklet actually. There it is. So solutions of a quadratic equation, you have this function here. So solutions of a quadratic equation, you have this guy here, which you must have learned in class at some point, but I'm going to show it to you here quickly. So basically for the zeros, you can use the function that your zeros, which we're going to be calling x. So x has to equal negative b plus minus square root of b squared minus 4ac divided by 2a. And so this, although it takes a couple extra steps, will always, always, always give you the zeros or the x-intercepts. So you just have to carefully plug in what is plug in what is a, what is b, what is c. So because our factory setting, or our original function, is ax squared plus bx plus c. Well, a is whatever is next to x squared. So a in this context is this negative 0.2. B in this context is whatever's next to x to the power of 1. See? So b is going to be 2.3. And c, well, there is no c here. So technically there's like a plus 0. So c is going to be 0. So having all of that, we can now plug in. So you end up with negative 2.3 plus or minus square root of 2.3 squared minus 4 times negative 0.2 times 0 divided by 2a, which is 2 times negative 0.2. So basically you end up with negative 2.3 plus or minus square root of 2.3 squared, because this guy is 0, it all goes away, ¿cierto? Divided by, we did this earlier, negative 0.4. I'm pretty sure, we can double check. 2 times negative 0.2. Yeah, there's the negative 0.4. And so square root of 2.3 squared basically cancels each other's out, but I'm going to invite you to put in the calculator anyways. So you end up with negative 2.3 plus or minus 2.3 divided by negative 0.4. And so from here, if you focus on the zeros I gave you down here, with respect to the axis of symmetry, one is going to the right and one is going to the left. And so one is more positive, another one is more negative. That is why there's the plus or minus here, because essentially from here they're telling you, hey, where is the zero that is more to the right? Well, that is the version where you do the plus sign. What about the one that is more to the left, or whatever, ¿cierto? Or it's not necessarily left or right, but it's for one or the other, see? And so the other one is going to be the same version, but with a negative here instead of the plus. So be very aware, this is a negative, be very aware of how this gave you two versions, which is for like the two zeros, yeah? So this first one, if you plug everything into the calculator using alpha, y equals first one for a fraction, you can do negative 2.3 plus 2.3 divided by negative 0.4, which gives you 0. And then over here we have the same version, but up top we put a minus here, end up with 11.5. So one of your zeros is right on 0, which makes sense. It's right when Luigi the dolphin jumps, and this other one is going to be right on 11.5. So the horizontal distance when the dolphin re-enters the water will be the x-intercept of 11.5, 0. If you want to be more specific, I guess you'd say 11.5 meters. And you're showing your work or your method is all of this right here. If we check the answer key, it does say the 11.5, and here we have very clearly that equaling to 0 shows conceptually that you know what you're doing. You're trying to find the x-intercept. So just equaling this to 0, just understanding the concept, already gives you 1 point. So that would be for part C. Now for part D, we have explain what a negative h value would mean in this context. Perfect, yeah. So first things first, what the heck was h? So h, up here we can see, is the height of the dolphin above the surface of the water. And so when h is positive, Luigi the dolphin is above the surface. But if h equals -2, then that means that Luigi the dolphin is down here. So they would be below the surface of the water. So part D is a little more intuitive in this case. What I can share with you is that the moment you read h value, you start thinking, what the heck was h? And thankfully up here they defined h for you. So h is height, specifically above the surface of the water. So h being positive means you're above, h being negative means you are below. And so A negative H value will mean that Luigi the dolphin is underneath the water, which is exactly what they tell you here. The dolphin is below the surface of the water, is underwater, is in the water. See? And the other big brain answer that you can give is that H cannot be negative because in theory the model talks about when Luigi the dolphin is jumping, not where it is at every second. So that would be the answer for part D. And the last thing I can mention for part D is that it is worth only 1 point. See? It is worth only 1 point, and it is a context question. And so notice that for part D, you needed nothing from part C, B, or A. You could have answered only part D and gotten 1 point and skipped everything else. Do you want to do that? Probably no. But if you are low on time, you have 5 minutes left, and your brain is already like a little bit melted from the IB test, it can be a good idea to be on the lookout for these exercises just to answer them quickly. You can answer part D without everything else and still get 1 point. So if you are clawing for points, be on the lookout for this kind of exercise. See? Especially if you're low on time and you know you're not going to solve an entire problem, try to solve those context exercises quickly. All right, ladies and gentlemen, that would be for number 5. I hope it helped. And Luigi the Dolphin says, take it easy. All right, you guys. So number 6 is an exercise that is hard to think about, but the math is not super complicated. Okay? So take it as a challenge of how you think about shapes and this and that and the tools you have at hand. So we have that a child's game is played by making paths in the snow. First, 2 circular paths are made using the same center O, and basically we will have the radius of a smaller circle. So the smaller circle would be this one. So you have this smaller circle, and they tell you that the radius of that is 2.8 meters, which is what they express here. So from here to here, you have 2.8. And they also tell you that the radius of the larger circle, so this guy here, is 4 meters. So the larger circle would be bada bim, bada boom, right over here. And the 4 meters they're talking about is like from here to here. So that is how you can tell that they have the same origin, they have the same center. But one of them creates a large circle, the other one the smaller circle. Then they tell you that additional paths are then made from O, as we can see all these lines that are shooting out. Blah, blah, blah. Dividing each circle into, this is the big concept we have to really make use of. Dividing each circle into 5 equal sectors. So that means that this sector is equal to this sector, is equal to this sector, is equal to this sector, and is equal to this sector. And so that is basically what they mean by equal sectors. So you have sector 1, sector 2, sector 3, sector 4, sector 5, and they are all equal to each other. That's basically what they're trying to go for here. And so for your calculations, ignore the widths of the paths, okay, whatever. And that each region between paths will be colored with an environmentally friendly dye. Good to know it's going to be environmentally friendly. The shaded region will be colored orange. And so Maureen, our good old friend Maureen, has enough orange dye to cover an area of 6 meters squared. And we need to, for part A, show that Maureen has enough orange dye to cover the shaded region. First thing I can point out is that because it just says show that, this is actually true. It's like, hey, prove this thing that I know is true. That's what show that is telling you. And the good thing about a type of exercise with show that is that technically you can skip ahead to part B. And if part B needs something from part A, you know that part A is true. And so that can be a good test taking strategy. In this case, we will be attempting to show that this is true. But if you're low on time, you can skip ahead and use information that this is true. You know, that's what I mean. Anyways, so yeah, think about it this way. You need to find the area of this guy here, right? Now, we don't have any formula for the area of like the sector between two circles, and like there isn't really a name for this shape. I mean, there must be, but not a friendly one that we can think of. There isn't really like a friendly formula we can embark upon. And so finding the area of just that guy here is a little bit harder to do, okay? Now, I'm pretty sure there's two ways to solve this. And so the first one I'm going to show you is, for me, the more intuitive version, okay? The thing is, you can find the area of the circle in green and the circle in yellow, okay? So the area of a circle in your formula booklet is right here. So that your formula booklet, you need to learn to love it, use it, everything. It's going to save you the day of the test. It saved me. It can save you. So area of the circle is a equals pi r squared, where r is radius. So let me first write that down. We have that area of a circle is going to be, wrong letter. Pi r squared is an area of the circle. So the area of our good old friend in green is going to be pi times its radius 4 squared, which ends up giving you 16 pi. And you can leave it in terms of pi. And this yellow one ends up being pi 2.8 squared. And I may be a boomer, I have a lot of tricks up my sleeve, but I do not know what 2.8 squared is. So let's find out. 7.84 pi. And so the entire area in green is 16 pi. The entire area in yellow is 7.84. And so, just so that we all agree, all of this is 16 pi. And all of that is the 7.84. And so if I right now do the dark green minus the dark orange, so I do 16 pi minus the 7.84 pi, well, what are you left with? If you have the dark green being subtracted by the dark orange, the area that you're left with is all these little bits here. So everything on like the outer ring is what you're left with, right? And from here, you have everything in the outer ring, okay? But you need to get only this part of the outer ring. But notice, of this entire outer ring that we're talking about, let us recall, and this is why it's important to highlight buzzwords and key concepts, let us recall that this outer ring is divided into 5 equal sectors. And so that means that whatever this result is, which let's find it out now. So 16 minus this guy. So 8.16 pi. If I go ahead and divide this by 5, you end up with only this guy here, which is exactly what we're going for. So 8.16 divided by 5 gave us 1.63. 2, I think it was 2. And so basically, for showing that marine has enough orange light to cover the shaded region, we would say that 1.632 meters squared is less than 6 meters squared. It's very important that because it says show that, you have to give a reason, and this would be your reason. And mathematically, the powerful thing here that the IB is looking for is that you use this symbol there for less than. So very important for getting full credit. If we look at the answer key here, we have attempt to calculate the area of a circle using 4 or 2.8, which is a little bit what we did, times 1/5 because we have 5 equal shaded areas. And here they ended up with 5.13, which is interesting. So we trolled somewhere, but where did we troll? We trolled because this is 1.632 pi. So if I leave my answer in terms of pi, actually I can't leave my answer in terms of pi. Okay, I'm very glad that happened on screen. It gives me the opportunity to correct myself. We need to compare the orange dye Marine has to 6 meters squared. And right now I have everything in terms of pi, so it's not comparable, ¿cierto? So we're gonna take this 1.632 and multiply it by pi. And that gives me the 5.12, which is this 5.12. Yeah, perfect. So this is actually 5.12. Actually, let's see it here. 707. If you want to leave it in significant figures, you count 1, 2, 3, round it up or keep it the same. You can round it up. And so 5.13 is less than 6. And so this would be showing how Marine does have enough orange dye to cover the shaded region, because the shaded region is 6 meters squared and the area we need to cover is a little bit less than that. All right, so I'm glad that mistake happened because it can happen to anyone, and goes to show you gotta be extra careful when handling pi. Maybe my suggestion now would be multiply by pi right away so you have like an actual number and you don't forget pi like I did. But the procedure is what matters here. See, so the idea was having very clear that we have equal sectors, and so you can easily divide by 5 in order to identify this guy. See, that is like the biggest step, I think, in this exercise. The other way we should be able to solve this, so I'm just going to show this quickly, you can skip ahead to part B if you're satisfied with this, is that we do have the massive buzzword sector. And so the minute you read the word sector, you should be thinking in your formula booklet. Why? Because your formula booklet does have an area of a sector formula, okay? And so area of a sector is this guy here. So we're gonna solve this through that now, okay? So area of a sector is theta divided by 360 times pi r squared. Now, this theta thing, theta is like almost always used to express angles, see? So let's actually first talk about what is a sector, see? And so the two main things you have for this part of the formula booklet is length of an arc, so that's also an important word, and area of a sector. If you have a circle that looks like this, and you have something that looks like that, this would be what we call the arc, because it is arcing just a little bit, right? And your sector is whatever is created because of that arc. And then this would be the sector. Okay, so that's the key idea we have to go for. This is an arc. The thing on the edge, that's why it talks about length. And the thing inside is what's created by that arc. That's why we talk about area. Anyways, enough blah blah. What we can try to do here is get this sector. Sorry, give me a second. We can try to get this sector and subtract it from this sector, and we end up with this itty bitty part. So that's another game plan we can go for, which is what we will go for, okay? And so the part in blue, we need to first express our angle, ¿cierto? And so the angle is, you basically have an entire circle which was divided into 5 equal sectors. So you can take the sum of angles in a circle and divide it by 5. So you must have heard of 360 no scopes. Well, here's a 360, you flip around, ¿cierto? So 360 divided by 5 gives you that angle of 72. So you can express 72, which is basically the angle here. This angle is 72, okay? How did you discover? Because you did 360 divided by 5. Here we multiply by pi, and here we multiply by r squared, which in this case, the one in blue, is the 4. So 4 squared, and then the guy in dark green would be again the 72 degrees, still part of the 5 equal sectors, times pi, but a much smaller radius, which would be the 2.8. squared. So all of this into the calculator, we have 72 divided by 360. This time we're going to multiply by pi right away, times 4 squared. And so that would be the thing in blue. The thing in green would be 72 divided by 360 times pi times 2.8 squared. And that gives you 4.92. You do the blue minus the green, you end up with only red. 5.12707, which is the same 5.12707 we got here. See? So that is two ways to approach this. I think the thing of the circles, like big circle minus little circle, is probably more intuitive for most people. But I do invite you to really take into account the approach of identifying the word sector and going straight to the sector formula. Okay? Basically, I'm trying to transmit to you, the minute you read the word arc or sector, you should be remembering your formula booklet. You should be entering this realm of your tools, okay? And if you don't, well, you have the intuitive approach I told you just now. So it's never bad to have an additional tool added to your toolbox. That would be for part A. Then for part B, our good old friend Maureen tells us that during the game, the players start at the entrance and must travel only along the paths made in the snow. Maureen travels from the entrance along the path showing in the following diagram. So following the arrows, our good old friend Maureen started here and then went this way, 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 and this way. Very exciting. And so good old friend Maureen had fun, and then they told us to have fun and tell us, hey, what about if you calculate the distance they traveled along this path? Starting from the entrance and then returning to the entrance. So basically just calculate the distance of all of these lines over here. Okay? Now, part B is not super hard. In fact, I think it's probably the friendliest 3 points in this entire test. But again, the hard part is thinking about the exercise. So this figure we've already gotten a little bit more familiar with. See, we have the big circle we talked about. We have the little circle we talked about. And we have all these equal paths going around, right? So having that in mind, let's try to establish what each of these like lines is, okay? What do I mean by this? You have one line that goes from here to here. You have another one that goes from here to here. Another one from here to here. Another one from here to here. And another one from here to here back. So we're going to call A, B, C, D, and E. Okay, that's the first thing we can sort of try to establish. So you have this part, which is A, this part, which is B, C, D, and E. Now immediately we can tell that these three, I don't know why that happens. Let me try a different approach. We can establish that these three are the same, right? They just happen in different places, but this is a perfectly equal circle, equal distances, equal this, equal that. So EA and B is basically the same distance, while C and D is also the same distance. See? And so let's first go with C and D because I think it's a little bit more friendly. C and D is going from the center O, from the origin, all the way out. Center O all the way out. Center O all the way out. Ah, okay. So it's part of the big circle. It's part of the radius of the big circle. We can say that C equals 4 and that D equals 4. So that already solves D and C. EAB is a little more complicated because it forms part of the big circle again, but it's the curved line on the outside. So it being a curved line is a little more annoying. there's two ways to approach this. We're going to show both. The first one is that because it's part of the outer circle, and what you know about the outer circle is basically this, we have radius 4, that's it. You can try to calculate the perimeter of the circle, which is the same as the circumference. So you can try to discover the circumference of this circle. And because we know that it is equally split into 5, I did not draw that as I should have. Because we know it is split, maybe this is a little better, whatever. Because we know it's split into 5, you can again divide by 5, get each of these and figure it out. So that's a lot of blah blah, but let's jump into it. Basically what I'm telling you is that you can go to the from booklet, look up the circumference of a circle where you have c equals 2 pi r. And so you can do c equals 2 pi r. So circumference equals 2 pi times 4. Let's put all of that into a calculator. So 2 times pi times 4, which gives you 25.1327. So circumference is 25.1327. 4.123. So this circumference that we just discovered is this entire distance. So you discover that all of that, all the thing in blue, is the 25.132. And so if you want to find E, A, and B, well, it's what? It's 1 part, 2 parts, 3 parts out of the 5. So you can actually do this same circumference, but multiply it by 3 over 5. Because E, A, B make up 3/5 of the entire circle. And you know it's divided into equal sectors, so that is also why you can do this approach. So you end up with EAB being 15.0796. So E plus A plus B is giving us this 15.079, 6444, 74. And to find the entire distance, we have to do A plus B plus C plus D plus E, which is just going to be this 15.079 plus 4 plus 4. So basically this guy plus 4 plus 4, bada bing, bada boom, you end up with 23.079. 0.079 6444. And if you do significant figures, you would count 1, 2, 3. Do you round it up or keep it the same? You round it up. And it is talking about distance, and it is talking about meters. So you can leave it as 2.31 meters. And that is exactly what they express over here. See? So as you can see, one approach is doing the circumference, multiplying by 3/5, and then one thing leads to the other. You add the 2 4s, you get the 23.1. So that would be one way to solve part B. The other way to solve part B is a little bit the challenge of discovering what E, A, and B is. See? Now I did tell you earlier that you need to be on the lookout for ideas like sector and arc. See? And I told you that arc is like the length that is right outside, right? And you can also think about it that way. I mean, you have an arc here. And this arc is the same as the other two. So you discover one, you discover all of them, right? And so for this arc here, well, we already know that this is 72 degrees, as I showed you earlier. And you already know that this distance from here to here, because it's part of the radius of the big circle, is 4. So that's basically all you need to know, because over here, from the booklet, length of an arc is length equals theta divided by 360 times 2 pi r. And so the length of just one of these guys, so this length here, for example, from here to here, is going to be the 72 divided by 360 times 2 times pi times r, which is going to be 4. So all of that into our trusty rusty calculator. And you end up with something like this. So that's the length of one of these arcs. So just E. And to get EAB, you gotta multiply that by 3. And it gives you the same 15.079 we got here. See, so it's a way to also get, discover the length of the arc. You add the two 4s, you again end up with the 23.079. So the numbers are literally the same, so you can believe me on this. But yeah, so that is one additional way for figuring out B. What is my suggestion? My suggestion is that the intuitive version of finding the circumference and then times 3/5, or up here doing the big circle minus the little circle, is probably your more intuitive approach. So if that's what came to mind when you face this exercise, by all means go for it. At the end of the day, whatever floats your boat, do what is best for you. Get familiar with the tools you want to get familiar with. But it will invite you to aim to use length of arc and area of sector. Why do I say this? Because I have seen IB tests where you can only solve it if you know of this formula or of either of these formulas. And yes, it's in your formula booklet, but what use is it if you haven't practiced with it? If you haven't gotten familiar with it? If you don't know that this even exists, okay? And so length of an arc, area of a sector is definitely something I see in the IB tests. And they usually say the word sector or they say the word arc. And that's a big hint. You gotta go here. You gotta try to solve it through this. Okay, so for this exercise, thankfully there was the intuitive approach, but that is not always gonna be there. So don't depend on it. I suggest that you depend a little more on this. I guess you shouldn't ever depend on just one thing, but I can tell you that this is way more likely to be the method you're gonna end up using the day of the test, more than the big circle minus little circle and etc. See? It's not that it's bad, but area of sector and area and length of an arc is far more common, and again, there are exercises where you can only solve it through that. So might as well practice this method a little more. Yeah, enough talking by me. That would be for Maureen and her game. That is for number 6. All right, guys, number 7, we have that children inherit genes from their biological parents that determine their eye color. Good to know, Mr. IB. They tell us that Maria and Alex, high school sweethearts, plan to have 5 children. I don't know about you, but who nowadays plans to have 5? That's crazy. Anyways, the probability that a child born to Maria and Alex will have brown eyes is 0.75. It is assumed that a child's eye color is independent of any other child's color. So the things we're going to point out here is that they plan for 5. The probability that they're talking about for brown eyes is 0.75, same as 75%. And we assume that the eye color from one or the other is independent of any other child. And so Maria and Alex wish to predict how many of their 5 children will have brown eyes. So for part A, it's only worth 1 point. So it's also skippable because it's a context question. But it says to state one criterion in addition to independence that would support them using a binomial distribution to find probabilities for their prediction. Now, the first thing we need to talk about is a little bit the intuition of a binomial distribution. So binomial distribution, following its name bisexual, by this, by that, it's like for 2. Okay, bi is for 2. And so a binomial distribution, the heart of it is that your possible outcomes are only 2. Okay, it's like heads or tails. And in this context, it would be brown eyes or not brown eyes. That's why the probability, as you can see here, is that they have brown eyes. So it's either they do have brown eyes or they don't have brown eyes, period. All right. So one of the criterions we can already mention, knowing that we have this binomial distribution going around, is that the probability is always the same for each child. The other thing that is important for binomial distributions is that Maria and Alex plan to have 5 children. Okay, so the total amount, and this gets a little more technical, but the total amount of trials, in this case children, is fixed. So they plan to have 5, they will have 5. The total amount of trials is fixed. So that is basically the heart of binomial distributions. You have the trials that are fixed, and the probability is the same for each child. So if we go over here to the answer key, we can see that number of trials or children is fixed at 5. Only 2 possible outcomes, which is the heart of the binomial distribution, bi for 2. And the probability of brown eyes or whatever is the same for each child and outcome. And so any one of these works, might as well mention a couple, you're going to get one of them correct. So that would be for part A. It's basically just understanding what the heck a binomial distribution is. And now for part B, you need to calculate for part I that exactly 3 of the 5 children will have brown eyes. And so actually we're going to go ahead and tag both of these at the same time, BI and BII. Why? Because the tools you need to know are very, very similar. As you can see, part BI talks about an exact amount, while part BII talks about an at least amount. And so, what do I need you to know? I need you to know that, first of all, this is a binomial distribution exercise. It will not always be obvious. Okay, it will not always be obvious. In this case, it kind of is because it talks about a binomial distribution. But the big hint that you are in a binomial distribution problem is that you have a fixed trial, and that the probability is very heads or tails. It's one or the other. It's only 2. So they either have brown eyes or they don't have brown eyes. See? And if also they talk about something like independent eye color, this or that, it's further reason for having it be a binomial distribution. Now, if you go to your calculator and you say, okay, I'm going to do something a little bit fancy, I gotta go into distributions. You can press second vars, hit the distribution button. And as you can see, there's a bunch of stuff here. And notice how most of these have PDF, CDF. Over here, you also have PDF, CDF. And scrolling down for long enough, you will find binomial PDF and CDF. And so the intuition you need to have for the tools, okay, the calculator tools, is that PDF is for an exact amount, while CDF, we will think about it as for an interval. Quite literally. And so for BI, you already know you have to use PDF. And for BII, you already know you have to use CDF. Okay? So PDF is for an exact amount, CDF is for an interval. Once we have that organized in our brains, for part BI, we can go ahead and hit binomial PDF. See? Now I need you to be aware of the following. The procedure we are going for right now is, first, we identified its binomial. Second, we have the knowledge that our calculator has these 2 functions. And third, we recall that we have PDF and CDF, okay? And this is the bit of information that you have to have very clear. PDF is for exact, CDF is for interval. Here it says exactly, we're going for PDF. And notice, I have not yet mentioned what PDF asks for, what we need to plug in. This is merely us following the procedure of reaching this point in the calculator and knowing that it's PDF. That is what I need you to know. What comes next is just intuition and figuring it out on the spot, because let's be honest, you're not going to remember everything about the calculator and how everything works, but you should be able to reach this stage comfortably, okay? That is what I challenge you to be able to achieve. And so you tap on PDF and boom, this is where we're going to turn on our brains, and it says you have trials, you have P, and you have X value. Trials will be the amount of times you will be doing this thing. In this case, doing thing is having children. So trials will be 5. And P is pretty much always probability in these type of functions and stuff. See, so probability would be probability to have brown eyes because they are asking for 3 of the 5 to have brown eyes. Brown eyes is 0.75, so you put 0.75. And then the X value is, well, because PDF talks about exact values and they're asking for exactly 3 of the 5, P value is naming that exact value. So you would put 3 here, go ahead and click paste. And there, to show your work, you can express binom PDF, parentheses, 5, 0.75, and then this 3 that showed up. Now, why is this showing your work? Because this is telling the IB instructor, hey, I went to my calculator, I went to binom PDF, and the first thing they asked for, I plugged in 5. The second thing they asked for, I plugged in 0.75. And the third thing they asked for, I plugged in 3. And so, you plugged in 5 for trials, 0.75 for your P, and 3 for your X value. And all of this makes us end up with 0.263,671. Which, if you leave it as significant figures, you would count 1, 2, 3. Do you round it up or keep it the same? You round it up. You can leave it at 0.264. 26.4%. And then we head on over here, over yonder. You can see that bada bim, bada boom, there is a 2.64. And part of showing your work is expressing, hey, I'm using the binomial distribution with this probability, blah, 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 blah. Yeah, excellent. That is for part B. Part B double I is fairly more challenging because when it talks about at least, it's a little bit harder to manage. See, so CDF is for intervals. Okay, CDF is for intervals. And so in this case, they're saying that at least 4 of the 5 children will have brown eyes. At least 4 of the 5 will have brown eyes. And so the big challenge that happens here, okay, the big challenge that happens here is that essentially some of us have these like super duper calculators, yeah, which allow you in this step for CDF to be able to express if you want to do at least or greater than, all right? But us plebeians stuck with the TI-84 cannot do that. So if you can't do that, make use of it and take a minute to appreciate your privilege, because that is important to do in life. It's always important to appreciate. And those of us that don't have that, okay, what we will have to do is, again, it's 5 trials. Again, the probability is 0.75. That has not changed. But here we actually need to express an X value of 3. So think about it this way. They're saying at least 4 of the 5 will have brown eyes. And so this is implicit when they say at least 4 of the 5 have brown eyes. It's the same as saying that you're going for the probability of 4 have brown eyes or 5 have brown eyes. And if I actually draw this distribution, just to make it a little more visually appealing. So you draw your binomial distribution. I'm going to assume it looks a little bit like this. I don't know. Here you have 1, here you have 2, here you have 3, 4, and 5. Basically, and I know this isn't like fully representative, but it will help me explain my idea. Okay, so the idea is that when you use binomial CDF, it will always give you that amount or less. So that is like the thing that happens here. So, and this, notice, more than like understanding the binomial distribution or understanding, you know, the function and math and this and that, it has more to do with understanding how your calculator manages it. So, and I always say for the AISL test, you know, A third of it is understanding the formula booklet and the methods. The other third of it is understanding like the graphing calculator, and the last third of it is your attitude. See, así que this is the part where you just have to know how your calculator works. See, so binomial CDF will always give you, unless you have the option, which in this case I don't, maybe you do. Binomial CDF always gives you that or less. And so the moment that I express this x value of 3, it means that I am getting the probability of x being less than or equal to 3. And so if you have to discover that at least 4 of the 5 have brown eyes, which is the same as having 4 or 5, because it's at least 4, ¿cierto? That means we're talking about this section here. And this section here, effectively, is the probability of x being greater than or equal to 4. And binomial CDF cannot give me greater than or equal to. And so what you actually have to do is plug in less than or equal to 3, because you can only do less than, ¿cierto? So you plug in less than or equal to 3, which, again, I know it's not fully representative, but technically it gives you something like this. And so you can do 100% minus the probability of x being less than or equal to 3. And this will give you the probability of having x greater than or equal to 4. That is basically how we have to do it if we can't choose the greater than option or the at least than option. See? And so that is what we have to do. That is why we calculate x value being 3 here, because it gives you x being less than or equal to 3. Binomial CDF always works, and this is a more intuitive approach. It always works like left to right. So as you can see, you plugged in 3, ¿cierto? So it gave you the probability from left to right, ¿cierto? And you couldn't do from, well, I guess the thing in pink would also be like left to right. But how do I say this? It's like, it will always be, binomial CDF is always from the approach of less than. And so if it's at least 4 or 5, it's greater than or equal to 4, ¿cierto? And so because binomial CDF is only for less than, it sort of like starts from 0. Maybe that's a more intuitive thing to say. It starts from the 0 and it just counts to the right, ¿cierto? Because that's how it works, you might have to do 100%, which is all of the probability subtracted by the thing in blue to get the thing in pink. So that is exactly what we do. The thing in blue, basically a probability of 3 or less is 0.3671. And so we take 1, which is 100%. See? Remember that. 1 is 100%. 0.5 is 50%. And that 0.05 is 5%. And so 1 being 100%, we do 1 minus this probability here, which is the probability of blue. So it's less than or equal to 3. And so you're finding the opposite of that when you do 1 minus that. And so you end up with a probability of greater than or equal to 4. So this is like the big brain play we have to go for. And so this is what ends up giving you the thing in pink. And the thing in pink is 0.6328125. If you want to think about it in terms of significant figures, you can count 1, 2, 3, round it up or keep it the same. You round it up, so you can leave it at 0.633 if you'd like. And over here, that is exactly what happens. And so as you can see, one of the methods that the express you can use is recognizing the cumulative probability with a lower bound of 4. So that is if your calculator allows you to express the lower bound of 4. But if you can't, then you are forced to take this boomer approach, 1 minus x being less than or equal to 3. And so this is the boomer approach. And some of your calculators will be able to have you express immediately the greater than or equal to. Some of us will, some of us won't, but we all can. And that's the beauty of this world. All right. Anyways, that is for number 7. and that is the binomial distribution. The biggest thing I can share with you is this. PDF is for exact amount, CDF is for an interval, and that knowledge is also useful the day of tomorrow when you face a normal distribution. For normal PDF and normal CDF, inverse normal is a little different because you like plug in an area and get an X value, okay? But the knowledge of what PDF and CDF is for is very useful in both cases. Anyways, enough talking by me. That is for number 7, and I hope it helped. Ladies and gentlemen, number 8 up until now is the most violent question of this entire test. It's the most violent question of this entire test because it's not very friendly. I mean, look at this thing. What the heck is even happening here? Negative exponents? Like, someone was having a bad day and they said, let's make these students have a worse day. Anyways, happens, that's life. Back to this exercise, we have to consider a function of the form f of x equals this, and they tell you that b and c are constants, and that the graph, this is just a fancy way to say like your graph, okay? Your graph has a gradient, so this is huge information, of 0.208 at x equals 5. Quick reminder, gradient is the same as slope. And so for part A, you need to determine the value of b. Now, the hard part here, I think, is realizing which procedure you have to use, okay? And so the two things I need you to really, really have clear is that here you have f of x equals this nasty thing. And they also tell you, for apparently no reason, that at x equals 5, the gradient is 0.208. And so the hard part here is understanding how you can have this bit of information interact with your function. And so the question I give you now is, can it interact with your function right now? And the answer, unfortunately, is no. If they would have told me something like at x equals 5, y equals 3, then yeah, you could plug in x equals 5, y equals 3, and try to solve for b and c. But they're telling you that at x equals 5, the gradient is 0.208. And so when you have a function like this, like simply f of x, you plug in an x, you plug in y, you get sets of points. Makes sense, see? And so how does the gradient enter this world here? It enters this world here when you talk about derivatives. So, why? Well, because think about it this way. When you have f of x, it's just like your original function, your normal thing. It's just you plug in x, you plug in y, you get your sets of points, whatever, see? But the minute you have derivative, the derivative of the function, now what's happening is that essentially on the left, you are saying when x equals 2, what is y? Okay. And over here in the derivative version, very, very intuitively, you're saying when x equals 2, what is my gradient? That is the massive change between the original function and the derivative function. In one, you plug in x, you try to find y. And in the other one, you plug in x, you discover the gradient at that point. And now the next question some of us might be asking ourselves is, why the heck is it useful to know the gradient at such and such point? Well, it's useful because let's say you're analyzing something like a parabola. Let me use a color that's a little bit different, maybe this one. And so let's say you're trying to find the maximum point, see? And so you really don't know what x is. all right? You don't know what x is at this maximum point, but what you do know for a fact is that the gradient equals 0 at that maximum. Well, how do you know that the gradient is 0? Well, the gradient here, if I were to draw a straight line, is positive, right? So I don't know, m equals 3, just to make it up. And then the gradient, I don't know, here is also positive. But it's a little bit less positive because, I mean, it's still growing, but it's growing less, ¿cierto? But right around here at the maximum, it's a flat line. And so the slope equals 0. So that is why for a lot of these exercises, probably not in this case, but for a lot of these exercises, what actually ends up happening is that you take your derivative and you equal it to 0. So your entire function equals 0 because that helps you. That is actually asking something a little bit different. It is when my gradient is 0, what is my x? That is what this thing in green is asking. When the gradient is 0, what is my x? Down here, it's a little bit different. When x equals 2, so for example, you plug in 2 here, ¿cierto? What is my gradient? See, those are two different questions that happen, okay? And both of them can be very useful. So the main idea we have to draw from here is that in your original function, it's like you plug in x, you get y, bada bing, bada boom, no worries. In your derivative version, suddenly the question you're now answering is in regards to gradient, okay? So up here, you have that f of x is this whole nasty thing, and they tell that at x equals 5, the gradient is 0.208. You can't simply plug in, not yet. You first gotta get the derivative. And so, what the heck is the derivative of this? I think it's, well, actually, let's start over here. So, there is in your formal booklet, there is the derivative of an exponent. So of x to the power of n is the derivative of an exponent. And what I need you to really focus on is what the heck is happening to this exponent. So more than the derivative of x to the power of n, I'd rather have you remember it as the derivative of an exponent. Okay? So in the derivative of an exponent, two things happen. Let's see if you can figure it out. Okay? Take a second to think about it. Focus on the n. What is happening to the n? What is the n doing? You can pause the video, try to figure it out. 3, 2, 1. The exponent, what it's doing is that first it multiplies in front. So that's the first thing it does. So the first thing that's going to happen is that exponent multiplies. In front, I like to think about it as below. So it multiplies below. See, so it jumps down and it multiplies. And also, you have the exponent minus 1. So the exponent multiplies below, and the exponent does a minus 1. That is literally the derivative of an exponent. So if we go back over here, this derivative means that for this first term, the 2x to the power of negative 2, first we're going to have the negative 2 multiply in front. So you end up with 2 times negative 2. Then I express the x, and I have minus negative 2 for the exponent, but we still have to do minus 1. So here are the two things happening. You first have the negative 2 multiplying below, and then you have the minus 1 up top. Quite literally. Okay, so that would be for the first term. And for this second term, I mean, there's a plus, but it ends up being negative, so we end up with negative, okay? B, which is one of the things in front of x, times negative 1. Actually, wait. I don't want to mess this up. Give me a second. So first, let's put this plus. Let's not get confused. We have the b, which will be multiplied by negative 1, because it's the exponent jumping down. And then you have x to the power of negative 1 minus 1. And the last thing, which is very interesting, is this c. And so some of us might be thinking in regards to the derivative of an exponent, so the c is to the power of 1, so maybe I multiply by 1 and this and that. Like, I get why you might be thinking that. And something that I forgot to mention, which is incredibly important, so my bad, is that these derivatives, okay, is always in regards to your variable, because this is x. And so derivative of an exponent is always in regards to your x value, you know. And so this c, because it is not multiplied by x, because that is not a thing that's happening, c technically just disappears, okay? The other way you can think about it is that technically there's an x to the power of 0, and so you end up with 0 multiplying in front. Okay, that's a little bit of a more big brain approach for anyone that's not convinced. Technically, you do have x to the power of 0, which, by the way, anything to the power of 0 is just 1, so it's valid because you multiply by 1. But essentially, you have x to the power of 0. The 0 is going to multiply in front, so you end up with 0 times c times x to the power of 0 minus 1. But because you multiply by 0, it all goes away. Okay? The more intuitive thing I can share with you is that if it doesn't have your variable, it simply disappears. So this c will not appear below for the derivative function. Anyways, let's organize this a little bit more. You end up with 2 times negative 2, so negative 4, x to the power of negative 3. And here, instead of the plus, we now have the minus b, x to the power of negative 2. So this is now a successful derivative. And because it's worth 5 points, this is probably already like a method point. See? So notice that even if you don't get to the very end of the exercise, just knowing you have to do a derivative gives you like 1 or 2 points. All right. Let's remember that in the original version, you have x is 2, what is y? And in the derivative version, you have when x is 2, what is my gradient? Or also the other way around, when my gradient is 0, what is x? In this case, you have both pieces of information. They tell you at x equals 5, the gradient is this. So that means that this whole thing is gradient. So careful with that. This whole thing is gradient. So you can plug in 0.208. Now, the gradient is 0.208 only where x equals 5. So you end up with negative 4 times 5, because you plug in 5 for x to the power of negative 3, minus b times 5 to the power of negative 2. And so this isn't particularly friendly. Let's be honest, it looks nasty. But we successfully plugged in the information into our derivative function. And that's what matters at the end of the day. So from here, let's just use our calculator as much as possible. Let's be honest, why would we not? For this first term, we have this negative 4 times 5, and that 5 is to the power of negative 3. So that first term gives you, so you end up with, give me a second, you end up with 0.208 equals negative 0.032, and then you have minus b. You have minus b times something. So actually, let's first figure out that something. So that something is 5 to the power of negative 2, 0.04. So you end up with 0.04b. And because you want to find the value of b, you want to try to get b alone. And so what I would do is do plus 0.032 plus 0.032. So that means we end up with 0.208 plus 0.032, 0.24. So 0.24, claro, equals negative 0.04b. And so now for finding b, you gotta divide by negative 0.04, divide by negative 0.04. So b equals, I'm pretty sure that's like 6. Well, let's just try hard a little bit. Divided by 0.04. Yeah, 8/6. So careful, it's negative 6. You do divide by negative 6. I missed that small detail. So this b equals negative 6. They look awfully similar, but this is b equals negative 6. And so that would be the value of b. So b equals negative 6. If we check over here, we can see that just evidence of derivative gives you a method point. Okay. Even an attempt to use the power rule gives you a point. Substituting 5 for x and 0.208 for the gradient. So this is this step here in red. Okay. And you end up with b equals -6. Right. Perfect. So that would be for part A. For part B, we now need to show that f of x is increasing at x equals 3.5. So as I told you earlier, ¿cierto? In this mini diagram here, you can go discovering like your x values with respect to the gradient, ¿cierto? So the cool thing is that when you have the derivative version, you have two ways you can answer questions. The first is plugging in a value for x and discovering the gradient. And the second one is giving it a gradient and discovering x. Okay, so you either give the gradient, discover x, or give x and discover a gradient. So up here, what is happening? You need to give an x in order to discover the gradient to see if that gradient is increasing or decreasing. So let me repeat that idea. At f of x, we have that, we need to show that actually that we need to show that f of x at x equals 3.5 is increasing. And so because your derivative, you can give it an x value and get a gradient. Well, if that gradient is positive or negative, it will help you understand that the slope or the function is increasing or decreasing. Why? Because down here you can notice, let's say that this is, I don't know, x equals -1. In this imaginary example, if you plug in x equals -1, you end up with a gradient of 3. And so you know that at x equals -1, the slope is increasing. Let's say that this x over here is, I don't know, like 3. And so at x equals 3, you can discover that the slope is not increasing or decreasing. It's just flat. See, so that would be a maximum or a minimum. And then later on, I don't know, x equals 5, maybe here, you discover that the slope is now aiming downwards. So you would get a slope of, I don't know, -1.5. See? And so that is the kind of thing we need to attempt to discover. So up here, we need to show that f of x is increasing at x equals 3.5. So what we can do is take our derivative function, which is -4 x to the power -3 minus b, but we just discovered that b is 6. So minus 6. Okay. Here I am. So minus 6 x to the power -2. X to the power -2. It's the same as writing our derivative, -4 x to the power of -3 plus 6x to the power of -2. And so show that f of x is increasing at x equals 3.5. You need to plug into the derivative function to find out the slope to see if that is increasing or decreasing. So notice, that's another big brain thing that I do need to point out. We need to show that the original function is increasing at x equals 3.5. So if I plug in x equals 3.5 in the original function, all you're going to get is the x comma y of the original function. You're going to get literally the point. And that's not enough to know if it's increasing or decreasing. So you're better off plugging into the derivative function to get the slope, and that will tell you if it's increasing or decreasing. So from here, we can plug in 3.5. So that means we end up at -4 times 3.5 to the power of -3 plus 6 times 3.5 to the power of -2. And so all of this plugged in to our trusty, rusty calculator. You have -4 times this 3.5 to the power of -3 plus 6 times 3.5 to the power of -2. So that gives you 0.3965, 0.3965. And basically, because this is greater than 0, it is increasing. So that is your argument. That is the part of the show that you have to do. So showing that is giving a reason. Your reason is that this gradient is greater than 0, so it has to be increasing, which is exactly what happens around here. So quite literally, Here it says your derivative is, the value of your derivative at x equals 3.5 is greater than 0, or it's positive, so it has to be increasing. Like, that is literally your reason. And your method would be something like plugging in your x equals 3.5 into this. See? Actually, here is more formally what we went for. So that is how you would solve this thing called number 8. And the important thing that I think is what most people don't fully understand, and it actually took me a while to understand, is how the original function changes when you enter the derivative world. Earlier, you plug in x, you plug in y, you're discovering coordinates. And over here for the derivative version, now your questions are for answering gradients. So if you plug in x equals 2 like here, you discover a gradient. Or the whole thing, you equal it 0 to discover what is x when the gradient is 0, which is a very different question, see? And I know that technically this also gives you, like all of this gives you x, y coordinates, see? But what changes mostly is what y means. And so y in this context turns to gradient, and y in this other context is just like a set of points. So that is the big brain change we have to really look out for, and I hope I was able to make it a little bit more clear. Enough talking by me. That is for number 8. Alright guys, number 9 is super hard, and before we jump into it, if the day of the test you read an exercise like this and you'll say, damn, I don't really know how to solve this, notice how they are both worth 2 and 2 points. While up here, something like number 8 is worth 5 and 2. I mean, part A already is worth more than the entirety of number 9. Why do I say this? It's important from the test taking strategy that you focus more on points rather than on the question. So this entire question is pretty hard, and in total it's 4. And number 8, well, it's also kind of hard, but not as hard as number 9, I think. And it's worth 5. Okay, so test taking strategy, be on the lookout for that kind of stuff. But let's still jump into number 9 and see how we can solve this. So they tell us, consider this nasty ass function, which looks like this. F of x equals x to the power of 3 minus 9x squared. It's not very friendly. And they tell you, notice, for this. And intuitively what this is telling you, for x values between 0 and 5. That's basically what it's telling you. We will only be evaluating this exercise for x values between 0 and 5. And so the graph of f of x crosses the x-axis. So basically x-intercepts. When x equals 1, when x equals 5, and when x equals a. And for part A, you need to find the value of a. Very exciting. And so, if we take a good look at this function, we can realize that it's messed up. It's very hard to manage, mostly because of this thing to the power of 3. If this were something like a parabola, then we would have more tools, or a quadratic function, and I might tell you equal it to 0, maybe use the quadratic function and stuff like that. Maybe you can try factoring, maybe you can figure it out through that way. But in this case, because you have something to the power of 3, all the tools that us humans have don't help us anymore. Everything in pink is for a quadratic function, and here you have what we call a cubic function because it's to the power of 3. And so that being said, we first pray, and then we open up our graphing calculator. And so, how can the graphing calculator help you here? Well, it can help you because the graphing calculator is useful for identifying x-intercepts, okay? And so how do you figure that out? Well, first we're gonna go to y equals and go ahead and plug in this entire very friendly function. So you can plug in x to the power of 3, you can plug in minus 9x to the power of 2, you can plug in 23x, and you can do that minus 15. Now, very likely you're going to press graph and you're not going to be able to see the graph how you would like to. So in this case, we can kind of see it. We can tell that there are a couple x-intercepts going around, but we'd rather have it look a little bit nicer, see? And so from here, my suggestion is press zoom, scroll all the way down to fit, and see how it looks like, okay? So zoom fit can oftentimes be enough for you to understand what your function is doing. Okay, but in this case, it's still not as friendly as I would like it to be. So the idea is that you do zoom fit to get an idea of the function, but then you pop the window to have it a little bit more clear. So because the x values go between 0 and 5, this can help me a lot for defining my window here. So we could put x minimum is 0, or actually we're going to put a -1 just to see it a little bit better, and then x max is going to be 6. And then my y's, for some reason, they went super mega high, so I'm just going to put -15, maximum 15, and see what happens. And this, for me, looks a little bit more friendly. And so for here, even visually, we probably already know what A is. We can see the x-intercept of 1 here. So this x equals 1 is there. And this x equals 5 is here. And so A is probably 3, but it's always worth double checking. And so you can go to second and then press trace to hit calc. And here you don't have a symbol for x-intercepts, but you do have a symbol for zeros. Now, why is zeros x-intercept? Because it's very common that, for example, you have f of x equals x cubed minus 9x squared plus 23x minus 15, and they tell you A. Your point A is wherever we cross the x-axis, and wherever you cross the x-axis is an x-intercept. And an x-intercept, what do they all have in common? The thing that they all have in common is that they all have something, 0, because they're all flat on the x-axis. That is why we have the 0. And so the thing you can do here is you have 0 equals all of this. And that is why your calculator likes to call this approach zeros. Okay, that is why over here it says 0 for calculate. So you press 0, and from here you can see that it asks for left bound and right bound. And the idea of left bound and right bound is that it helps you define which 0 you are going for. Because here you have 3 zeros. You have this one, and that one. And so if you put left bound here and then right bound there, you can basically tell your calculator, hey, scan for zeros between these two bounds and tell me what you get. And that's why this third thing is guess. Your calculator doesn't need to guess. Your calculator knows, but your calculator needs to know which one you're going for. So in this case, we're going for this 0, which is exactly at x equals 3 and y equals 0. Bada bing, bada boom. Basically, your way for showing the work is that you can express that this went into your y1 and that you did calc 0. So this would be for your method point. I end up with 3, 0. So a equals 3. Okay. Just to show a little bit more the zeros function, let's say you have your left bound aquí and your right bound all the way over here. So in this case, we are asking our calculator to scan all of this, ¿cierto? And your calculator, when they scan all of this, is going to discover 2 zeros, this guy here and this guy there. And so that is why the guess function helps. Again, it's not that the calculator needs help guessing, but it does need help understanding which one you're going for. So it's going to scan and find both. But if my guess is over here, then it's going to give you that one. Okay, and if your guess is elsewhere, it would give you the other one. I think that is why the calculator works the way it works. As I tend to say, the IB test for AISL is split into 3 parts. The first one is the formal booklet. The second one is the graphing calculator. This is the part of understanding a graphing calculator. And the last third is just attitude. Yeah, that is for part A. And now part B is much more juicy and it's only worth 2 points. It says use your graphic display calculator to find the area enclosed by the curve when we have between this. So when we have x values between 1 and 3. That is basically what it's telling you. See? Now, basically you need to find the area of this little guy here. So if I draw my function real quick, it looks like we have, here's 1, here's 3, here's 5, and it looks like we have something that goes, let me try to draw it well. So you have something that goes a little bit like boom, 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 right? And so they're asking you to find this area here. Now, unfortunately, not even in your formula booklet do you have something that talks about finding the area of this figure. Like, is this half a circle? Is this a fifth of a circle? It's just weird, see? And so unfortunately, you don't have a tool like that, like a formula you can use like straight away. But we do have the following concept. And this is something you need to have in your brain big time. If they talk about area under a curve, you will immediately say integral. So let's try that now. I say area, then I say curve, you say integral, okay? Area under curve, integral. Area under curve, integral. The cool thing about integrals, if anything at all, is that it helps you find the area under the curves. And that is actually what happens over here in the formula booklet. They tell you, hey, if you ever need to find the area of a region under a curve, you can use a derivative. Literally. You can use, not derivative, I'm sorry guys. You can use an integral for finding the area under a curve. And why is this useful? It's useful to know because whenever you see the word area and then the word curve, you think about integral. Yeah, perfect. So from here, you would have to do an integral, yeah? From the formula booklet, they tell us that the area for this thing under the curve is going to be integral little a, little b, y dx. And this, the math is not that hard, but the concept, I think, is like not friendly at all. And how it works with the calculator and everything, it's not very friendly, see? So this is part of the test that is, you either know it or you don't. See, it's not very friendly in that case, but hey, at least you're watching this video, so you're gonna know, see? So area under the curve, you pop an integral. This is how your integral looks like. And all you need to know is that this is for your minimum x value. This is going to be for your maximum x value. And this will be your function. Your integral symbol will stay the same. And this, just so that you guys know, is like with respect to which variable. And so it's the integral with respect to x. That's like all you need to know. See, so this is again something at the AISL level we're not going to touch. But maybe the day of tomorrow you're starting engineering or some crazy stuff. If this changes to dy, dx, dh, or whatever, that means, hey, you're doing the integral in respect to this other variable now. See? For us, we will always leave it as dx. So let's go ahead and plug that in, ¿cierto? So if we plug that in, we end up with the integral of your minimum x value, which in this case they tell us it's between 1 and a, so between 1 and 3. So that means that this minimum x value is 1. The maximum x value is 3. Y, we said, was our function, and our function is this guy here. So that means, and actually here as well, they tell you y equals f of x, see? Así que we end up plugging in x cubed minus 9x squared plus 23x minus 15 in respect to dx. And from here, there's two main approaches you can attempt to employ, see? One of them is actually doing the, actually no, it's not doing the integral, it's something different. No, because this is literally the integral. I don't think that's in the formula booklet actually, now that I think about it. All right, assuming that it's not, although it might be, I'm going to show you the method that I suggest anyways. So the first thing I'm going to point out is that usually for these integral exercises, doing this is already a whole ass point, see? And the other point is getting the right answer, see? But it's worth knowing that the IB focuses a lot on method points, and this is the big method step you have to do. Here you leave clear that you know two things. You know that for finding the area under a curve, you need to use an integral. And the other thing you know is that A is for minimum value, B is for maximum value, and that Y is your function. And so just expressing this as an entire method point, how would you solve it from here? Well, this is a very mathy thing to do. It's got a lot of mathy symbols. So in your calculator, you're going to press the math button. How convenient. A mathy thing, we press the math button. And over here, you're gonna search until you find it. And here we have fn int, which is not inting your Valorant games. It's int for integral. See, so fn int, so you pop fn int, and boom, look at that. It's your integral. And so notice how this right here, it's not that the math is super hard, but it is about knowing the capabilities of your calculator, knowing how to manage it. That is what the IB is really testing for you here. Were you able to learn the calculator, and were you able to understand the intuition of how it works? And it's just in general testing your method and approaches. See? All right, so the minimum x value, as we said, was 1. The maximum was 3. This thing in parentheses is your entire function, so trust the process, plug in your entire function. Always double check that you're plugging in correctly, no reason not to. And then here with the D, you do it in respects to x, so you just put dx. And here you press enter, and it does take a little bit, sometimes, not in this case, and you end up with 4. And so all of this equals 4. And this is in, they actually don't give you the units, but it is area, so I would just put 4 units squared. So over here in the answer key, area equals 4. So notice evidence of using an integral to find the area is a method point, and then the answer point is literally getting the point correct. See? So number 9 for me is a little bit harder because the tools you have to use are much more specific, but I hope it was useful for you guys to know that you can use the integral for finding the area under a curve. That's the most important part for me, and that also it is in your calculator, the integral. So if you ever need to solve an integral, this is the thing you gotta go for. Anyways, enough talking by me. That is for number 9. Alright guys, for number 10 we have that a manufacturer designs hats that businesses can order. And so for an order of, notice, 15 hats or fewer, the price per hat is P euros. While for large orders, the price of each hat after the first 15 is reduced by 5. And so C of N represents the total cost of purchasing N hats from the manufacturer. And for part A, we simply need to write down an expression in terms of P for the total cost of ordering 15 hats. So if we are ordering 15 hats, are we in this world for 15 hats or fewer, or in the large order world? In which world are we? If it is exactly 15 hats, well, large orders are after the first 15. After the first 15. So for now, it is not a large order. It is just a smaller or normal order. So we are in this world here. And in this world here, they tell us that the price per hat is P euros. So 1 hat is 1p, 2 hats is 2p, 3p is 3 hats, 4p is 4 hats, and so for 15 hats, it would simply be 15p. So that is for part A. For part B, it gets quite a bit more complicated because it says write down an equation for C of N in terms of P and N, okay? Basically in terms of, like Y and X, no, in terms of P and N, so using P and N for the total cost of ordering N hats when N is greater than 15. So now we are in the world of N being greater than 15. Now, this is not particularly easy. I feel like this is the kind of exercise that really challenges your math intuition and math skills. This does not have to do much with the formula booklet. It does not have to do much with the graphing calculator. This is the part of the test, which for me is the minority. It might be like, I don't know, 25% of the test. That really has nothing to do with any method from the calculator, any method from the formula booklet. It's just pure math intuition. So, C of n is for the total cost of purchasing n hats. And if we are for part B, we are in the world when n is greater than 15. Well, when n is greater than 15, the first 15 is p euros. And so the stuff we put from part A is useful for part B. Basically, I need you to think about intuitively as Cn as the first 15 plus the rest. And so the first 15, we defined that in part A, it's just going to be 15p. And then the rest is much harder to define, okay? And it's hard to give you like an intuitive approach, but I'm going to try my best, okay? The first thing we need to establish is that this thing of the price of each hat being reduced by 5 euros is basically telling you that, I don't know, like hat number 14 cost you p. Hat number 15 cost you p. Hat number 16 is now costing you p minus 5. Hat number 17 is also costing you p minus 5. Okay, that is like what's happening here. And as you can see, after 15, there's a massive change. See? And so the first thing we have to try to do is that for the rest, we need to add this condition that it is at least 15. I mean, sorry, it's at least 16 because it's after 15. So what we can do is that we can put n minus 15. So that's the first thing we're going to do. This is like the part where when we talk about the rest, which is basically maybe more intuitively, we can think about it as after 15. We need to make sure that it is indeed after 15. Now, why does n minus 15 help us in this case for n being greater than 15? Because if n equals 15 here, then this turns into 15 minus 15, so it just turns into 0. ¿Cierto? So if it equals 15, then the rest will simply equal to 0, so we don't care about it. And so this is our first condition for establishing como, oye, this discount only applies for after 15. So that is the intuition of this first parentheses. And so this is now going to be like our amount, okay? And this next one is going to be our price. And so the price, as we established earlier, is simply p minus 5, and we're going to stick to that intuition. Here we're going to put p minus 5. So again, not the friendliest way, there isn't like a formula to figure this out. This is again pure intuition. And so what I can share with you, or what I suggest, is first think about it as what are your first 15, what are the ones after the 15, plug in what you got for the first 15, and then for the rest, think about it as amount times price. Amount times price. You know that price is going to be whatever it is minus 5, because that is the discount, reduced by 5. And you know that the amount has to be greater than 15, so your condition is this minus 15. And so that is a little bit like the approach that's happening here, see? And so if we think about it, okay, and just sort of like to check, if we do 16 hats, that means that I would be plugging in 16 here, ¿cierto? So first we would do 15 times p, which is the 15 hats, ¿cierto? And then we would do 16 minus 15 times p minus 5. And as you can see, the cost of 16 hats ends up being the first 15 without any discount, plus 16 minus 15 gives you 1 times p minus 5. So it's going to be 1 hat with the discount. If I were to plug in, for example, 17, so if I were to plug in 17, then I would end up with 2 hats that have the discount p minus 5. So that's also a quick intuitive way to double check that our function makes sense, and thus far it does. So for part B, again, it takes a lot of like big brain energy. That's also why it's worth 3 points. This is how you write down the equation for cost of n when n is greater than 15. So Think about the first 15, then after 15, think always in terms of amount and price. See, in fact, even here you have amount and here you also have price. See, so taking that approach, I think can be a little more friendly. See? So that is for part B. Then we jump into part C where they tell us, hey, this company decides to order 100 hats because, well, why not? The mean price per hat for this order is 25.73 euros. And so for part CI, you need to calculate the exact total cost of the order. And so using our equation here, we can do C of 100. And you can plug in 15p plus 100 minus 15, and then this p minus 5. See? So cost of 100 ends up giving you 15p plus 85 times p minus 5. So cost of 100 gives you 15p plus 85p minus however much that is. So 85 times -5. Oh, by the way, the step I'm doing here, apologies, is I distribute this 85 multiplying here and here. So that's how we got 85p, and that's also how we end up with -425. So cost of 100 equals 100p minus 425. Ahora, I just realized something. So it's not a mistake, but it is a method approach, see? Is that for part CI, I saw calculate the exact total cost of the order. I immediately simply plugged in 100 hats into my function, and then it just kept going, right? But the issue that is arising here, okay, is that this doesn't exactly help you find the mean price per hat for this. I mean, doesn't help you find the total cost of this order, see? And so the total cost of this order, now that I look at it a little bit more closely, this doesn't help me figure it out, ¿cierto? Because you still don't know what P is, right? If I knew what P was, I could figure it out, but I don't. And so from here, actually what we need to do is that they give you the information, hey, I'm buying 100 hats. Each of them costs 25.73. So for part CI, what you actually have to do is take this 100 and multiply it by 25.73. And if you take that 100 and you multiply it by 25.73, you end up with 2,573 euros. So that would be for part CI. And if we check here, that is actually exactly what's happening. 2573, 2573. So that would be for part CI. Then part CII, it says, hence determine the value of P correct to 2 decimal places. So careful with that, correct to 2 decimal places. Well, now that you know that this order of 100 hats gave you 2,573, and here I am expressing for 100 hats, and this is cost. Well, this is how much it costed, right? So you can leave it as, you can plug it in, 2,573 equals 100p minus 425. And now, ladies and gentlemen, we can finally discover the exact value of p because we end up with only p over here. So that means we can do plus 425 plus 425. So that means that 100p equals this plus 425. So it gives you 2998. Then you can divide by 100 to both sides to get p alone. And you discover that p equals, if we divide by 100, you discover that p equals 29.98. And it's interesting because they tell you to leave the answer correct to 2 decimal places. And so if you do it to 2 decimal places, well, this is your second decimal place. Do you round it up or keep it the same? As far as I can tell, it's a round number that ends on 98. So leaving it to 2 decimal places, you would just leave p equals 29.98. And I assume that's correct. It is correct right here. So, bada bim bada boom, answer must be written to 2 decimal places. It is our case. And there we go. That is how you would solve number 10. So a little bit quick for part C. The weird part, I think, is for CI, that they tell you calculate the exact total cost of the order, and all you had to do was 100 times 25.73. And partly this occurs because we couldn't use our cost function yet. because we had this P going around, ¿cierto? And so we can't calculate the exact total cost yet. And so we are quote unquote forced to simply do this times this. There's no other way to discover the total cost of the order, yeah? The other thing I can point out is that I know part B is not the most intuitive thing and a little bit hard to like train or practice, but I do think what helps me at least is start from the very top. So start literally defining first 15 plus the rest, and then go plugging in slowly amount times price, and there you should reach something that makes a little bit more sense. Okay, so starting here, thinking conceptually as first 15 plus the others can be a little more friendly than tackling the whole sandwich at once. Okay. And the last bit that I can mention is that although these kind of exercises are hard because generating C of n is not particularly easy, the cool thing that you have to keep in mind is that in the answer key, for example, here it says part of your answer is correctly substituting their total cost into their cost function. So what does that mean? That you can completely mess up and fail the cost function, but if you are consistent and plug in as you should, even if it's the incorrect cost function, you still get an answer point. And so the other interesting part is that here, a method point is adding the cost expression, multiplying P and N to their 15. So even here, I guess it depends a little bit more on the examiner, but you can get a method point of attempting this, get the incorrect cost function, plug into your cost function, and here you get 2 points, even though your cost function could be wrong. And so that's also important to keep in mind. Just trying this exercise and really showing that you're giving it a good shot and being consistent with how you plug in can get you 1 or 2 points. As you get test taking strategy, always go for it. Method points are a thing. Why not? That would be for number 10. Hope it helped. All right, guys, for number 11, we have that Mongolia, okay, is one of the coldest countries in the world, with the air temperature in winter as low as -40 Celsius, which is crazy. I can't even imagine that. It can feel even colder if a wind is blowing. This effect is called wind chill. Good to know. So on a random day, someone told us that when the air temperature is -40 degrees Celsius, the approximate wind chill index W, so approximate wind chill index W, can be calculated by this equation. And they also tell you that V is wind speed in kilometers per hour. And so for part A, you need to find the approximate wind chill index on a day when the air temperature is -40 degrees, and the wind speed is measured as 13 kilometers per hour. Yeah, so this is a classic for IB. It's usually like one exercise that has something like this, which is basically challenging you to understand the context of the question and understand which variable is what thing. So they throw a lot of words at you, which is why we carefully highlight what I put in yellow. So we associate the variable W to approximate wind chill index, and we associate the variable V to wind speed. And so here when they say find the approximate wind chill index, what they're actually telling you is find W on a day when the air temperature is -40 degrees. Well, this equation is for -40 degrees, so that doesn't really change anything for us. So this -40 degrees is basically telling you use this equation. And the wind speed V, is measured as this. So in other words, what's happening is that they're telling you find W using this function when V equals 13. Literally. So V equals 13. What is W? That is what they're asking for. And so we go ahead and use this equation here. So W equals -34.1 minus 7.33 natural log, which is why it's ln, parentheses, our V, which is 13. So if we pop our calculator and do -34.1 minus 7.33 natural log, which is this guy here, so different, notice it's different than like this is different to this. Okay, so careful with that. See, we are talking about natural log in this case. Oh, and the difference, in case anyone's wondering, is that the base for ln is e and the base for log is 10. Unless you express a different one, okay, unless you express a different one, we assume it's e for natural log and we assume it's 10 for, you know, just log. Yeah, anyways, enough blah blah. We pop all of this into the calculator. We put that natural log and we put that 13 inside. Bada bing bada boom, you end up with negative 52.90. So W would equal in this case negative 52.90, I think I said. 9010 7879. If you were to consider significant figures, you count 1, 2, 3. Do you round it up or keep it the same? You keep it the same, so you can leave it as negative 52.9. Interesting. And so basically part A is just, as I said, the challenge is understanding what this is even asking for. So they use big words, they use hard words, and they try to throw you off. They put a lot of numbers and they try to confuse you, and the challenge here is understand the context of the problem. So this usually happens. They usually put a log in there, or maybe something with an exponent, like variable and an exponent. They usually try to throw you off with something like that. And part A tends to be like, can you interpret that this is simply talking about W, that this is simply talking about V equaling 13, and that this is simply talking about use that function. See, that is the challenge here. It's understanding the context and what they're really going for. See, anyways, for part A, we got negative 52.9, and here is that same negative 52.9. Notice how one of the points is plugging correctly, and the other point is getting the right answer. See, so you can plug in correctly, get the wrong answer, and still get 1 point. Worth noting. That is for part A. For part B, they get a little juicy because they say, or they tell us, that due to errors in the measuring device, because nobody's perfect, the percentage error in the approximate wind chill index, or W, calculating part A, could be as high as 6%. And so for part B, you need to predict the maximum and the minimum wind chill index for this day, knowing that the percentage error is as high as 6%. And so the big word here, I think, that should immediately be ringing a bell is percentage error. Ahora, ¿por qué? Why? Because a lot of this test, as I tend to mention, is a third of it is the graphing calculator, a third of it is the formula booklet, and a third of it is just attitude. And so knowing your formula booklet well, if you have been studying with it, and if you don't, you should start now. And if your test is tomorrow, you should know that the formula booklet is something that you will have the day of the test. You read the words percentage error, and it should be ringing a bell somewhere in your brain. Okay, somewhere in your brain, it should be going ding, 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 ding. Wait a second. I've read that somewhere before, and it is in your formula booklet. So that is when I say get to know the key concepts, get to know the key procedures, because you read percentage error, and it leads you to the procedure of opening your formula booklet and going to percentage error. And so percentage error looks like this. Basically, your error will equal your VA, which is the approximate value, so approximate for VA, and then the exact value for VE. So you have 2 exacts and you have 1 approximate. See? And so all of this will equal to you the percentage error here. See? So let me write that down over here for part B. We can write down first the equation. So it's going to be your error will equal these 2 lines, which is relevant. Okay, these 2 lines, I'll explain in a second. It's actually called absolute value. So absolute value of VA minus VE divided by VE. All of this times 100%. This 100% is just to contextualize that we are talking about a percent. See? These guys, the absolute values, the straight lines. See? It's different than a parentheses. Okay? You treat it the same as a parentheses in the sense that you work that out first, but the absolute value, what it does at the end of the day, is, for example, absolute value of 7 is 7. Absolute value of 2 is 2. Absolute value of negative 3 is 3. So if something is negative, it will turn it positive. Absolute value of negative 4 ends up as 4. So all it really does is whatever's inside, you keep it positive, okay? And so that being said, what we can do from here for part B is predict the maximum minimum wind chill index for this day, knowing that, and careful here, knowing that for part A, we found the, notice, we found the approximate. We found the approximate. This function was always for finding the approximate. So, this negative 52.901, blah, 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 this is an approximate. So this is what we will call our VA. And through all of this, you can discover VE, but you need to find the maximum VE and the minimum VE, and it's always moving around 6%. And so basically what this implies is that you will have one version where you have that the percentage error is positive 6%. So actually, we're going to write this percent as, actually, let's just leave it at 6% for now. See? Actually, no. Sorry for changing my mind so much. Percent, okay. We're going to get rid of this 100% as well, because for us, it's like very implied. We're talking about a decimal and this and that. 6% as a decimal is 0.06. 60% as a decimal is 0.6. And 100% as a decimal is simply 1. And so, one version is going to be where we have a plus 6%. And another version we're going to have is that we have a negative 6%. So on the plus 6%, we have that 0.06 equals the absolute value of our VA, which is negative 52.90107879 minus your exact value divided by exact value. And then your other version, maybe far more over here, you end up at negative 0.06 equaling the same thingy majingy, 879, but minus VE and divided by VE. So that is basically what's happening from here. See? Now, because you have two variables going around, okay, I mean, sorry, not two variables. Because you have the absolute values going around, but you still don't know the value of these variables, you just have to remember that you are dealing with only positive values like in here. See? But strictly speaking, from a more practical standpoint, remembering that you have absolute values here, you can't just try to solve this like getting rid of it for a second just to make it a little more friendly. Knowing that it ends up being positive values, you can visualize it like this, just assume that it's okay, and then solve for VE. See? And so this first step I would do for solving for VE is that we can realize that this VE on the bottom is very annoying, so you can multiply both sides by VE. Okay? The moment you multiply both sides by VE, this goes away with this, so you end up with 0.06 VE equals this negative 52.90107879 minus VE. And if you still want to get VE alone, you can do plus VE, which is basically plus 1 VE. So you end up with 1.06 VE equaling negative 52.90107879. You divide both sides by 1.06. And through the context of the problem, you can sort of figure out how much that should be in the sense of positive or negative. And so if you take this number and you divide it by 1.06, we end up with negative 49.9. See? And I know some of you might be thinking, hey, but what about the absolute value? Shouldn't all of this be, what is it called? Shouldn't this all be turned positive and this and that and etc.? And I say yes, but in the context of this exercise, VE, the thing that's inside, makes sense that it's negative. See, it makes sense that your approximate is a little bit higher and that your VE ended up being a little bit, so more than higher, it's more negative, ¿cierto? And your exact ended up being a little less cold than expected. See? And so this is a case where you have the positive percentage error, ¿cierto? So that would be what we call the maximum in this case. And although it's still a negative number, and it might look like a smaller negative number because you go from negative 52 to negative 49, remember that this implies that we are closer to 0. And if you're closer to 0 in the world of math, it does count as like a quote-unquote larger number if you're closer to 0 than before in the realm of negative numbers. See? And so that helps us identify the first maximum. And for the second one, it's going to be the same approach. So again, you multiply by VE to both sides. And so from here, we kind of know what's going on. So negative 0.06 VE equals this negative 52.90, blah, 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 blah. Minus VE. So here when you do plus VE, it's almost the same, but not quite. You end up with 0.94 VE equaling this whole thing. And so now when you divide by 0.94 instead of 1.06 like before, you end up with VE being equal to, so this guy, we now divide by 0.94. It gives you that negative 56.2777. 2777. 4339. And so as you can see, this would be our maximum and this would be our minimum, which makes sense because in the maximum we did the plus, in the minimum we did the minus. And in both cases, right, looking at the maximum, we passed from negative 52 to negative 49. So we're closer to 0. It's a bigger number. That would be our max. And then our minimum, we passed from negative 52 to negative 56. So it's even more negative. It's even colder. See, so in that case, we have our minimum or maximum. It's a little bit weird to think about because we are dealing with negatives, ¿cierto? And the absolute value in this case didn't matter too much because at the end of the day, like, think about it this way. Through this, we discovered what VE is. So it's what's inside the absolute values. See? So if you were to plug everything back in, you would actually end up with something like your VA. Actually, think about it this way. It would be your VA. It would be the absolute value of this minus, I don't know, let's do this exact, divided by this exact. So it would actually be minus minus, so this ends up being as plus. The minus minus is already there. And on the bottom it would be negative 49.90. 49.9066781. And all of this gives you that 0.06. See? And maybe in the other scenario, now that I think about it, we might end up with a negative 0.006. And then the absolute value helps you like correct for that. See? So the absolute value is more for correcting the percentage error thing, but the way we can treat the exercise is fine like this. See? Anyways, there you end up with the max and the min. And over here we can see that they do have the 49.9066. There it is. The 66 as well. And then the negative 56.2777. There it is as well. And you can see that part of the method point is actually using or attempting to use the percentage error formula. See here, literally you have the percentage error formula. And so that is why it's also important to keep in mind that the minute you read percentage error, bing, ding, 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 you should be going to the formula booklet. See, so get familiar with the formula booklet. All these keywords like compound interest, percentage error, geometric sequence, arithmetic leads you to the formula booklet, which leads you to a procedure, which leads you to a tool you can use. So that is the kind of level you want to achieve. That would be for number 11, and I hope it helped. All right, ladies and gentlemen, for number 12, we have that an airline restricts the size of bags by stating that the sum of a bag's width, length, and height, ignoring the handle, must not exceed a fixed value m, which is what they're saying right here. So width plus length plus height has to be less than or equal to m. And so a company is designing a cuboid-shaped bag. So something cuboid, think about it, it's like a cube, but it's not 100% a cube. So it's sort of like a rectangle that's trying to be a cube. Okay, so this cuboid-shaped bag, the company is designing this cuboid-shaped bag so that the sum of the bag's width, length, and height equals m, which is the thing we put in blue. And then they give us the very subtle but relevant information. Their design will have a length equal to 3 times its width. So length equals 3 times its width. Length equals 3 times its width. And so as the width of the design varies, they tell us that its volume changes according to this equation here, where W is for width and V is for volume. And for part A, we need to use a graphic display calculator to find the value of W that will produce the, careful, maximum volume. All right, there is so much going on here, a lot to go over. And I'm going to say right away that for me, number 12 is probably the hardest question in this entire test. For me. Why is it for me the hardest question of the entire test? Because for most people, they might handle stuff like derivatives, integrals, show that questions, volume, like you can have a general notion of that, but this question really challenges how you understand those concepts. And so although this is going to be a tough one, it's going to be a good example of how understanding concepts can lead to you understanding the problem, and it's not all about memorizing procedures. I know I talk a lot about procedures, and a lot of those procedures you can memorize them, but here, part of the procedure, you have to understand the concepts. Así que you can't only memorize procedures, you need to understand procedures. And so from here, the concepts are a little bit challenging. The first thing we will talk about is this rectangle I put in red, this equation here. So the first thing we have to understand is what the heck is going on there. This, what it's telling you, is that as W changes, V changes like that. And so these math symbols, the dV divided by dW, it is a derivative. Okay, that's the other big word here. It's a derivative. And derivatives are especially useful for understanding what we call rate of change, so how things change over time. And you might also hear it as slope. And so putting that in words, it's telling you as W changes, so the thing on the bottom, V changes like this. And let me correct this. Learning, not leering, changes like this. So as, what the hell? There we go. Wow, this is trolling me. That's interesting. As W changes, V changes like this thing in brown. Okay, that's the main idea of what's going on here. Okay, and so for part A, if it tells you to use the graphic display calculator to find the value of W that will produce the maximum volume, the big sort of thing we have to conceptually understand is that derivatives for rate of change, anytime you read the word maximum, you should immediately be thinking derivative equals 0. Okay? So first I'm going to show you like what the answer actually is, and then I'll show you why we're doing it the way we're doing it. Okay? And so whenever you read something like maximum or minimum, okay, maximum or minimum, and you have a derivative, or you can get the derivative, you have to pop the derivative and equal it to 0. So if you do your derivative equaling 0, it means you end up with 0 equals 690W minus 36W squared. And so from here, in order to solve for W, there's a couple different approaches. Okay, and the one that I will employ this time is that because you have something squared, claro, and your highest is something squared, you can employ or use the tools from the quadratic formula, which looks like this: a squared plus b squared. Sorry, ax squared plus bx plus c. Okay, it's like the same format, and the tool you can use here is the quadratic formula that goes like that: b minus plus or minus square roots of b squared minus 4ac divided by 2a. You probably have seen this in class, and if you haven't, it's still in your formula booklet. So in your formula booklet, I know it says HL, but it's still useful that it's here. The solutions of a quadratic equation, when you have a format like this, are this. So exactly what I expressed earlier. And in this case, I know there isn't exactly a plus c going around, but the plus c in this context is actually going to be a plus 0. So all we have to do from here, just to be very organized, is define a, define b, define c, plug in, chug, see what happens. So a is going to be whatever is next to the squared, so that means it's going to be this negative 36. B is going to be whatever's next to the x, that's to the power of 1, so that's going to be this guy here, so the 690. And c, as we said, is just 0. So if you plug everything in, you end up with negative 690 plus or minus square root of b squared, which is 690 squared, minus 4 times a times c, which is 0, divided by 2 times a, which is negative 36. So from here, you end up with negative 690 plus or minus square root of 690 squared. Because of this 0, all of this goes to 0 because it's multiplying, divided by negative 72. And so from here, you can do negative 690 plus or minus 690. Because since this is squared and it's also the square root, they're inverse operations. It's like doing plus 2 minus 2, nothing happens. So square root of something squared, nothing happens. This goes away with this. You end up with 690 plus or minus 690 divided by negative 72. And so one of these like versions or whatever is where you end up with negative 690 plus. And the other version is where you end up with negative 690 minus 690. So as you can see, what happened here is that this plus or minus took two paths. So there's one path where it's plus, one path where it's minus, and both of these can be your answer. Now, why does this happen? Because when you're analyzing a quadratic, ¿cierto? And you want to look at the solutions, the zeros, when you equal 0. So whenever you equal 0, you're analyzing this line here, ¿cierto? You can see that one of your answers is a little more to the left and one of them is a little more to the right. A little bit more to the left, a little bit more to the right. That's basically what's happened here. That's why the plus or minus exists in the first place. So one of these is actually going to give you 0 divided by negative 72, which is the same as 0. So one of my potential answers is 0. And the other potential answer is this 690 times 2 divided by that 72. Being aware that there's negatives on top and bottom, so it ends up being positive. 19.16667. 19.16667. And so realistically, if we're talking about maximizing our volume, through context, it doesn't make sense for our width, because this is width, ¿cierto? It's as W changes, how does your volume change? So width being equal to 0 maximizes your volume in one case, which is a little bit ridiculous, ¿cierto? And the other answer is suggesting us 19.16667. And so yes, having a width of 19.16667 would indeed maximize our volume. So for part A, we end up with width equals 19.1, bunch of 6s and a 7. All right, so that would be for part A. And now the quick explanation that I missed earlier, okay, which is a little bit of an extra but still relevant, is why do we put the derivative equal to 0? So think about it this way. I told you guys earlier, ¿cierto?, that derivative is what we call rates of change, or you might have also heard it as slope. And so if you have a quadratic that looks something like this, okay, and you want to find the maximum volume, well, your maximum is Duh, at your maximum. And so the question now is, how do you reach this maximum? Well, your classic approach, which is one of the first things you learn, is you go for the axis of symmetry, which is what cuts your quadratic and right down the middle. And your equation is this x value is going to be negative b divided by 2a. So that's what gives you the x value for the maximum. And after you have the x, you plug it into your function, you get dy. See? So that's like we usually do. And that is actually also in your formula booklet. See? Axis of symmetry, negative b divided by 2a. Yeah, so this is your classic. When you are in the world of derivatives, though, what you can do is think about it this way. The maximum or minimum always has a specific slope. Now, what slope is that? Well, think about it this way. If you're here, your equation is still growing, right? So the slope here would be, I don't know, positive 3. If you're standing over here, though, it's still growing, right? But it's growing a little bit less, so your slope would be, I don't know, 2. But if you're standing right on this maximum, then the slope is flat. The slope is 0. And so every time, whether it's the maximum or minimum, your slope will always be 0. And so that's why whenever you see the word maximum or minimum, and you have a derivative, pop it equal to 0 because the slope at the maximum or minimum is 0. That's conceptually the challenge here for us to understand the procedure. So much so that the answer key even says, hey, if you understand this concept, I give you a method point. So you can even get it wrong, but just writing this gives you that method point. So you literally get half the points in part A for understanding that concept. Good to know. Let's move on to part B. So for part B, they now tell us that we need to show that the maximum volume of the bag to 3 significant figures is 42.200 centimeters cubed. The first thing I'm going to point out is that because it's a show that exercise, that means that this is true. So the maximum volume is 42,200. And so that means that I could, if I wanted to, skip to part C and find the value of M, knowing that this is true. So that's the first thing I'm going to point out. If you're low on time and the show that exercise is getting really hard, you can skip ahead and just use part B as like a fact. See, that is perfectly valid. De hecho, a big hint here is that it says show that, and then it says hence. So it's like, hey, you have to use the stuff from part B. See? So that's the first thing I point out. You can skip this part, but we will not today. So show that the maximum volume of the bag to 3 significant figures is 42,200. The challenge here is understanding that this function right now is as a derivative. So it helps you understand as width changes, how does the volume change? And with what we did equaling our derivative to 0, we've discovered the width that maximizes the volume. But the challenge now is getting a function for volume. And so think about it this way. If you have the derivative version and you want to go back to the original function, what do you do? Well, if you go from original to derivative, well, you apply the derivative, makes sense, because you end up with a derivative version. But if you want to go from derivative back to the original, what do? Well, you got to do the opposite of a derivative, and the opposite of a derivative is our good old friend, integral. So if you pop an integral from the derivative function, you end up in the original. Okay. So for part B, we have our derivative, which is dv dw equals this 690w minus 36w squared. And we need to show that it reaches 42,200. All right, excellent. And so from here, as I said, you want to end up with the original function. Why do you want to end up with the original function? Because it's going to give you a function for your volume. And we need to show that the maximum volume is this, ¿cierto? So you need a function for volume. That's why we pop the integral. And so what the heck happens when we pop an integral? Well, the day of the test, you're walking in with a couple of things. You're walking in with 2 years of this experience called IB, 2 hours of sleep, a pen or pencil, eraser, a whole lot of motivation, your graphing calculator, and the formula booklet. Guys, I've referenced the formula booklet like 2 or 3 times already. You should be catching on to the fact that the formula booklet, you do walk into it the day of the test. It is your right. And it's useful. It's useful to know. It's useful to know what's in it. See, and so in here, we do have the integral of x to the power of n, which is the only integral, by the way, that you will be facing at the AISL level. Same with derivative. You only have that derivative, the one of the exponent. See? And so I know this might look kind of crazy, but let's try to understand it a little better. See? I really need you to focus on what happens with this exponent. So notice this, when you do the integral of this with respect to x, first thing you're going to do is do +1 up top and then divide it by your new exponent. And you're going to pop a plus c right next to it, which I'll talk about in a second. See? So let's say you have x squared. Well, following this formula, you should end up with your exponent +1 divided by your new exponent, which is 2 + 1. And then the plus c. If you have, I don't know, the 4x cubed, well, the 4 is going to stay outside for now. And you end up with x to the power of 3 + 1. Your new exponent is 3 + 1, all of this plus c. That's literally the integral you have to know. See? Now what I'm going to talk about is that this plus c, well, what the heck is it? This plus c is what we call a constant. Why is the constant relevant? Because if you have f of x squared plus whatever 2x plus 1, and you do the integral, you can click on another video to understand the integral, but basically, really quickly, notice this exponent. You're going to do -1. You're going to do -1 to the exponent, and you're also going to pop down multiplying just the exponent without the -1. See? So from here, you end up with x squared turns into 2x. This 2x turns into just +2 because you have x to the power of 1. So the 1 multiplies downward. And then this +1, because it doesn't have an x next to it, it just disappears. And the more theory-wise is that technically there's an x to the power of 0. So that 0 multiplies in front, that's why it disappears. Okay? But this is the derivative. See? And if I do an integral to try to come back, well, I do the integral of this and of this. So you end up with x squared plus 2x, because you're going back to the original function through the integral. And notice how this +1 disappeared. And so that is why we have to put a plus c, because we might have eaten up a constant without realizing it, because that is how derivatives and integrals work. This +1 disappeared through the derivative, and so when we do the integral, we have to be aware that we might be missing that value, that concept, that etc. See? Yeah, back to reality. If we do the integral from here, the rule I mentioned, so doing the integral, ¿cierto? Maybe to show your work, you can do like, I don't know, integral. You can write integral so they know you're doing the integral. And you end up with 690 will be multiplying outside, as I showed you. And then this w is to the power of what? It's to the power of 1. So that means you end up with w 1 + 1 divided by your new exponent, 1 + 1, close parentheses, minus 36 on the outside, open parentheses. Well, this exponent is w to the power of 2. So that means I should end up with w 2 + 2, sorry, 2 + 1, and then the new exponent, 2 + 1. That's literally it. So the integral, so now like your actual function, see? So volume with respect to w is going to be 690 w squared divided by 2 minus 36 w cubed divided by 3. And if you want to get fancy, and the plus c, don't forget the plus c. And if you want to get fancy, I guess you can't do the 690 divided by 2, which gives you 345 w squared, and over here the divided by 3 gives you 12, so 12w cubed plus c. And so here we just did the integral successfully, and the next challenge is how the heck do you replace c? The classic approach for replacing c, and I suggest you write this down somewhere, is that for figuring out your c value, plug in an x comma y point. This is like the tool you have for figuring out the next value. See? And so the x values you can use in this case are not too many. So again, this is another very challenging conceptual sort of approach you have to do. For the integral version, which is the volume right here, you actually don't have any literal point. See, so not yet. They didn't tell us like the maximum volume of this is when W is whatever. Actually, I think we do have that, now that I think about it. We do have that. We could try to solve it that way. All right, let's try to solve it that way. So because of context, they told us that when the width is this, we reach our maximum volume, which is that, because that's what the show that told us. ¿Cierto? So I guess what we can employ here is that we can say, okay, if our volume is this 42,200, and our width is what we've got from part A, so the 19.1666667, 19.166667 squared minus 12, 19.166667 cubed plus c. So this should help me figure out what the heck c is. See? So let's do this 345 times this 19. Let's put a bunch of sixes just so we make sure it's correct. Actually, I guess I could go like this to be very precise. Squared minus 12 times this guy here. Cubed. So all of that gives us the 246. 246 plus c. Ahora, I just realized, and I'm actually going to leave this in the video because it's fairly relevant. I just realized I made a small mistake. Firstly, I'm leaving in the video because anyone makes mistakes. That is the world of math. That is life. But secondly, the mistake that I employed here is that I said that this width equals this volume. But this volume that they gave us is corrected to 3 significant figures. So it's not literally the same volume. See, so plugging in this XY point that I proposed doesn't work in this case because what they gave us was corrected to significant values. So it's not the exact value. So there will be a margin of error, not good enough. So let's go back in time a little bit. Yeah. What else can we do? Well, a classic here is always thinking about plugging in something like 0. See, that's just like a plan B that tends to work. It can help you find out y-intercepts. It can help you find out even the maximums here, ¿cierto? And so in general, thinking about plugging in 0 can be good. And conceptually from here, what we can do is that if our width equals 0, what should my volume be? Well, if you have that this bag suddenly has width equals 0, we'll visualize it. Instead of having this distance, it would be no distance. And it wouldn't even be like a flat line. It would just be like nothing. It's literally equal to 0. And so when width equals 0, you can have that volume equals 0. And so this is another challenging concept in order to figure out plus c. And so if width equals 0, volume equals 0, so you put everything at 0 and see what c should end up as. And by now it should be a little bit more obvious. But you end up with c equals 0. See? And so because c equals 0, your final function looks like this. Plus 0, ¿cierto? And from here, now we can do the show that for the three significant figures of this. So now we plug in these 2 points, ¿cierto? Or actually, now we plug in just the width and see what we end up with. So plugging in just the width. So it would look something like this, the 345 times this guy here, minus 12 times this guy there. Cubed gives us actually what we calculated earlier. So this, ¿cierto? So that means that when you plug in this width here, which comes from part A, the volume it gives you is 42,246, comma. Actually, the comma's here, sorry. I'm a little bit Latino on that one. So 42, comma, 246.52778 thought in significant figures. You can count 1, 2, 3. Do you round it up or keep it the same? You keep it the same. So that means you end up with 42,200. The units are... Damn, what are the units? Centimeters. Centimeters cubed. So that would be how you show that rounded to 3 significant figures. Plugging in W into your volume function gives you that right here. See? And so the big challenge for me is that we need to understand that this function here is for rate of change. So it's not for finding literally your volume. This is telling you as your W moves, how does your volume move? While the integral version is literally when your width is whatever value, what is your volume? See, which is what we needed for this case. And once we reached that, we plugged in what we found from part A and got our value for volume. So that would be for part B. Last but not least, for part C, you need hence find the value of M. And so M is width plus length plus height less than or equal to M. So this is where it gets juicy as well. So from here you can say that W plus L plus H equals M. Damn, what do you do here? Well, think about it this way. What we can sort of like employ is something that we highlighted way in the beginning, which is the classic IB, giving a little bit of information in a couple words, and that's something that you have to use. See? The nice thing about the IB is that whatever information they give you, you pretty much have to use always. So it's not like other types of tests where they give you like a whole paragraph and you only use one sentence of information. Way earlier, we highlighted that the length equals 3 times its width. So the length equals 3 times its width. So that means we can plug that in here. So you end up with W plus 3W plus H equals M. So from here, 4W plus H equals M. And W, you actually already have it because, well, we actually already have it from part A. See? So this is our W value we have to go for. So really the question here is, what the heck is H? How can you try to find H? And so the big brain play we have to employ here, after giving it a couple rounds of thought, is which functions or expressions do you have which employ H? So you have the W plus the L plus the H equals M. That's one of them. What else do you have? Well, you've been working a bunch with volume. And what shape of volume are we talking about? A cuboid shaped bag. A cuboid, the volume of a cuboid is length times W times H. So notice how my knowledge of knowing that cuboid is in the formal booklet helps us generate this expression. That's what I mean by master the formal booklet. You don't have to be a super genius and know by memory the volume of a cuboid, but you read cuboid and you should know cuboid is in there. That is the level you need to reach. Yeah, so volume equals length times width times height. So we define that here. Length times width times height. From earlier, length equals 3w, so volume is the same as 3w times h, which is the same as saying that volume equals 3w squared times h. And you know that w is this guy here. And you know that volume from part B, we got the exact value here, ¿cierto? So you can express volume as 42,246.52778. So that's our volume, equaling 3w, w being this guy from part A, ¿cierto? So 19.16667 squared times h. So that will give us h, and then the h we plug in here, see? So basically, we use the expression for cuboid. So we can do 3 times this famous 19. That will have to be squared. So that means that 42,246 point blah, blah, blah. So our volume equals 1,100, what was it? 102 point, a whole lot of decimals. H, so H equals 38.3331. And now that we have our H value, we can plug it in here actually. We can plug it in here. So 4W plus H gives you M, which is 115, which looks just about right. So ladies and gentlemen, that would be enough talking by me. The hard part of part C for me is finding the two expressions. One of them is, well, the one they gave you, so this guy, complementing with this, and using this. All right. Number 12, not particularly easy, but very doable, much like anything in life. Ladies and gentlemen, I hope it helped, and I'll see you around. Last but not least, we have number 13, and I will immediately say right off the bat that there tends to be at least one exercise per test that is a bearing exercise. So we're going to talk about what bearing is in a second, but a bearing exercise is extremely common, and in my experience, once per test. If not in paper 1, it will be in paper 2. So our good old friend Tiki. Tiki is sailing a boat in the ocean because Tiki has a lot of free time. For the first part of her trip, she plans to start at point A and travel to point B. She then plans to turn and travel 13 kilometers, these 13 kilometers, on a bearing of 100 degrees, which is this 100 degrees here, to point C as shown in the following diagram. Makes sense to me. Due to navigational error in the first part of the trip, Tiki arrives at point D instead of point B. So she intended to go here and ended up there. All right, cool. Blah, blah, blah. Tiki arrives at point D instead of point B. Point D is 2 kilometers due west of point B. And for part A, we need to determine a bunch of stuff. The first one being the size of DBC. So first things first, when they say DBC like this, and that little hat here, it's telling you the angle B. Now, when we say angle B, we have this guy, we have this guy, we have this guy, we have this guy. So there's 4 of them, ¿cierto? So which angle are they referring to? They're referring to the angle B formed by D with C. And so whatever D and C creates will be angle B. Ah, that's why it's the little hat there for telling you, hey, it's whatever it's formed by those 2 lines. And so what is formed by those 2 lines would be angle B formed by DC. So they're asking for this angle here. Okay, so that's the first challenge we have to embark upon. How do you figure out what the angle in pink is? So think about it this way. Because of how this diagram is constructed, it might not be to scale, but intuitively and with everything that's happening, all these bearings are straight lines, this and that, and etc. And so what we can say here is basically identify that angle B, or more than angle B, or actually angle B, you can think about it as this entire circle. And so how many angles are in, or sorry, not how many angles, how many degrees are inside of a circle? So if you have played Call of Duty, not Call of Duty 7, the real Call of Duties, you know, the OGs, you know that you can 360 no scope your opponents. And so a 360 is when you spin around entirely once. And so one circle is going to be 360 degrees. Now think about it this way. The 360 degrees, this portion here that I'm putting in green is explained by this 100. This portion in pink is what they're asking for part AI. And this portion here, ladies and gentlemen, well, how much is this? It's a little bit hard to see the red, but I think there it's a little more clear. This portion here in red, well, how much is that? That would have to be 90 degrees. Now, why is it 90 degrees? It's 90 degrees for a couple of reasons. The first reason, okay, is that they tell us that point D is 2 kilometers due west of point B. So it's not saying a little bit higher to the right, a little bit higher to the bottom. It's saying due west. So you can think about that as straight west. Straight to the west, 2 kilometers. So essentially what I'm arguing here, okay, is that this line is a straight line. And so as long as I prove to you now that this line is also a straight line, well, then it's 2 straight lines perpendicular to each other, boom, 90 degrees. See? How do I know that this second one is a straight line? I know that it's a straight line because of how bearing works, okay? Now, how the heck does bearing work? The way you use bearings, okay, let's imagine I start here and I tell you, hey, I am going to travel 2 kilometers on a bearing of 30. That means I go this way. Ahora, ¿por qué? How did I reach that? So this is the 2 kilometers, okay? And the bearing of 30 means that wherever I start, or wherever I say that, ¿cierto? I draw a line up, perfectly straight, signaling north, and then I count my degrees until I reach 30. And so right around there would have to be my 30 degrees. So bada bim bada boom, there are my 30 degrees. That is how bearing works, see? Ahora, how do you apply that in a more practical sense? Let's say that you have, or actually more than saying, you need to have this knowledge, see? If you start at this point here, and you draw the line north, you have to remember that over here would be 90 degrees. Over here would be 180. This is thinking in terms of bearing, okay? And over there, it would be in terms of 270. And if you come back, well, it's a full circle, it's 360. So as you can see, I'm adding 90 each time. If you come back, it's 360. Makes sense. And so essentially with this knowledge here, now whichever bearing I tell you, you can figure it out. So if they tell you, for example, they traveled, again, 2 kilometers, but bearing of 35, 2 kilometers bearing 100, 2 kilometers bearing 260, and 2 kilometers bearing 300. So with what I just taught you, all of this should be a lot more doable. This first one, which I'll be doing in red, we can say, well, bearing of 35 is between this north, which is like 0 degrees, ¿cierto? And this 90. So as long as I put a line somewhere in this direction, well, those are my 35. See? This one over here, which I will be putting in whatever green, would be 2 kilometers bearing 100. So 100 is between this and this, ¿cierto? So 100, I'm just going to eyeball it like over here. And this would be 100. So that is my 100 degrees. This guy here, for 2 kilometers bearing 260, well, 260 is between this guy and this guy. So I'm going to draw it over there. And 260 would be all of this angle there. That would be my 260 degrees. And last but not least, the one that I'm going to do in whatever, maybe this color here. 2 kilometers I'm bearing 300. So 300 is between this guy and this guy, thinking that this is 0 degrees, or you can also think about it as 360. You would end up drawing a line maybe here, and your bearing would go like this. Boom. So there is your 300 degrees. Anyways, that is basically bearing. Okay? So, as you can see, for all of these, your starting point was, well, here, and thinking in a straight line up north. Thinking in a straight line up north, straight line up north, straight line to the west, perpendicular, 90 degrees. So this circle is composed by red, which we just said is 90 degrees. It's composed by green, which they told us is 100, and is composed by pink, which is the remainder. So you can do 360 degrees, which is your circle, will equal the 90 degrees plus the 100 plus the thing in pink. And so that means you end up with 360 degrees equals 190 plus the thing in pink. So the thing in pink is going to be 360 minus the 190, which gives you, let me clear this, 360 minus the 190, bada bing bada boom, 170. And if we check over here, it looks just about right. So that's first things first for AI, 190 degrees. Took a little bit long for explaining part AI, but also we did take a minute to explain bearings, so now what is left should be a little more friendly. Part A double I, we have the distance from point D to C. So from point D to C would be, give me a second, let me make this diagram a little more friendly. So we discovered that this is 90, so I'm going to put that here. All right. We discovered that this is 170. And now they're asking for, yeah, actually, let me make this even smaller. So this is the 170. And then they're asking for this line here. Yeah, so they're asking for the distance from point D to C, which is this entire line that I just drew in black. That is what you're trying to figure out in this context, okay? Now, not exactly friendly, but it does seem doable. Now, think about it this way, and this is also like a classic sort of bearing thing that happens a lot, see? In bearings, you're gonna end up with a lot of triangles. And so if you have a lot of triangles, you need to be thinking in your formula booklet in for triangle, trigonometry, everyone's favorite unit. And so for trigonometry, we will skip HL only because, you know, we can just laugh at them. We are SL. We don't have to know all those fancy identities and stuff. We only need to focus in these three. And so for trigonometry, you have sine rule, cosine rule, and area of a triangle. Now, all of these are for triangles. And so if my tools are for triangles, well, let's think in terms of triangles. And so the triangle we have here, which I'm going to draw it in a different sort of proportion so it makes more sense. You have D, then you have B, then you have C, and then you have that DC that we drew. See? And so you know that this guy is the 170. You know that this distance is 2, and you know that this distance is 13, and that you need to find this x value here. See? That is the information that we have at hand, and that is what we need to work with. So what the heck do you do? Well, once you identify it's a triangle and you draw it and you know that your tools are trigonometry, the 3 tools you have are sine rule, cosine rule, and area of a triangle. The area of a triangle one is awfully specific, so whenever they ask for area of a triangle or this or that, or they give you the area of a triangle, you need to consider this as a tool, okay? Especially in the world of trigonometry, a lot of times just knowing this exists can help you solve an exercise. But in this case, I'm going to focus more on the procedure of trying to discover sides and angles. So if you need to discover a side or an angle, first sine rule, then cosine rule. That is what I suggest for the more intuitive sort of interpretation or procedure or whatever. See? And so how the heck does sine rule and cosine rule even work? What the heck are these letters? Who decided adding letters to math was a good idea? So you can notice you have big letters and small letters. You have these also nasty things that say sine, cosine, etc. See? The big letters and small letters do matter because the small letters in the formula, ojo, in the formula will be sides. So if you have side A, that means you have angle A because it's associated. If you have side B, then you have angle B. And if you even think about it the other way around, you have angle C, that means you have side C. So this does go both ways, okay? Basically, little letters are going to be your sides, big letters, angles. All right, we're actually gonna write this somewhere here. Small letter side, big letter angle. The other way you can sort of remember that is that when you use sine or cosine, the angle always goes inside. You might have seen in class something like sine theta, and that's because theta is a typical symbol in math for referencing a degree, for referencing an angle, or maybe something like a radian you might have heard, but it's for angles, okay? So sine and cosine, whatever is inside will always be an angle, and everything inside of the sines and cosines are big letters. Entonces, okay, big letter angle, that means small letter side. So if we're talking about small letter side and big letter angle, well, this sine rule tool that we have, it has 2 equal signs, see? So first and foremost, that means you can look at it like this. You can look at it like this. Or you can look at it like this. And the other thing we need to have extremely clear, and for now we're going to look at it like this, okay? The other thing you have to have extremely clear is, now that you know that small letters are sides and big letters are angles, is that intuitively you can rewrite this as something like this. You can rewrite it as side 1 divided by sine of angle 1 has to equal side 2 divided by sine of angle 2. Also, suddenly, once you learn the formula, and all these formulas actually, you should be able to define it in more intuitive terms, like something like this, okay? This is just what I suggest, but this is basically the level you need to reach. At least for explaining it to someone, you should be able to explain it like this. You're talking about side 1 that goes with angle 1, side 2 which goes with angle 2. You choose which one is the first one. You choose which one is the second one, pero ojo, be consistent. It's side 1 with its angle 1. A with big A. Little b with big B. Así que ojo con eso. Very, very important. All right? And so if we go back in time over here. Oh, and also the procedure, as I said, is first sine rule. And if it doesn't work, go to cosine rule. See? So for this this method here, think about it this way. If you have 3 out of 4, you can solve. So that means if you have a pair like this guy and this guy, and you have only one side, you can discover the last angle. Or even the other way around, you have one pair and an angle but not a side, then you can discover this guy as well, because it would be, you would have 3 out of 4, you would have only one variable to discover. See? So in that sense, if you ever identify that you have what I like to call a pair, so you have a side with an angle, you have maybe A with A, then you can probably use sine rule. Okay? If I go over here, do you have a pair? Well, you only have one angle, ¿cierto? And this angle is facing this X. And so the 170 degrees is associated to X, and you don't have any other angle. And so in this case specifically, we do not have a pair. And so we couldn't use sine rule. We're going to go ahead with cosine rule. I could probably give this a couple loops and a couple tries and maybe discover this angle or this angle and then go for sine rule. But in this case, I'm going to stick to what I'm telling you. If you tried sine rule and it didn't work, just go with cosine rule. See? And now explaining cosine rule a little bit more, you're going to see that you have two versions of the formula because of this semicolon. It's basically telling you use one or the other. So you either use this one on the left or you either use this one on the right. Now, pop quiz. With what I told you earlier about little letters, big letters, and all that fun stuff, ¿cierto? One of these versions is c squared equals blah, blah, blah. Another version is cosine c equals blah, blah, blah. So which one would you use for discovering a side? If you want to discover the missing side, you would use this one here because the side is already alone. And if you want to discover a missing angle, you would this one on the left because the angle is also already alone. And the only other thing I can sort of attempt to mention is that you need to notice that if you're trying to discover your missing side, you need to have its respective angle. So if I rewrite this more intuitively, like when I said side 1, angle 1, and all that stuff, this would have to be side 1 equals side 2. Oh, yeah, and all of this squared, ¿cierto? Plus side 2 squared minus 2 side 1 times side 2. So there I'm doing the minus 2ab times cosine of, ojo, side. Oh, wait, I think I trolled you. Pardon. Let me go again. So C is going to be side 1. A is going to be side 2. And so B is side 3. Apologies. Let me go again. So minus 2ab, we have minus side 2, which would be A, times side B, which would be 3. And so notice that small detail that even I messed up, see? It's important to understand these formulas really, really on a deeper level, see? And so you define what is side 1, what is side 2, what is side 3. As long as you're consistent, it's fine. In this case, you gotta be consistent with whatever you define as C, okay? If whatever you define as C, you have its corresponding angle, you're good to go. Technically, if you switch these from location, like switch 2 with 3 or 3 with 2, nothing would change, but you do have to be extremely aware that side C, you need to have angle C. And so in this case, basically, we can say that side 1 is the one I'm trying to find, which is X. Side 2 is going to be 2. And then, of course, side 3 is going to be 13, which makes sense, ¿cierto? So, lo and behold, you have all the sides. And you're only missing the X, ¿cierto? And for the cosine rule, specifically, you need the side, you need the angle of the side you're trying to find. You need the angle of the side you're trying to find. You need the angle, which is this 170, of the side you're trying to find. So angle 1 is 170. That means we can use the cosine rule. See? Now, I know some of you guys might be thinking, how the heck do you know you had to use the cosine rule there? It is so hard for me to see that I have the angle for the side I'm trying to find, so that means I use cosine rule. Yes, it's not easy, but in my experience, once you identify it's a trigonometry problem, this method will always work. It's never not worked for me. The IB builds it like this. See, if you can use sine rule, then it's just go with it. And if not, they have to give you enough for a cosine rule, or else you literally can't solve the problem, because these are literally the only tools you have. Ahora, if you try cosine rule and you realize you're missing information, then yeah, you might have to fill in the diagram a little bit more and this and that. But at the end of the day, they are aiming for you to understand the cosine and the sine rules. Yeah, enough blah blah by me. Let's bring over the formula. So the formula, as we can see, is this guy here. So let me rewrite it. Okay, so the formula C. Let me rewrite it with something a little more bright. No, not bright. A little more visible. C squared equals A squared plus B squared minus 2AB times cosine C. So as long as you're consistent, we can plug in this C, the side I'm trying to find is X. And then the other two sides, we're just going to say that 2 is A and 13 is B. So notice how I am defining what is side 1, side 2, side B, side 3, digo. So we can leave this first one as 2 squared. The second one is 13 minus 2 times 13 times cosine of the angle of the side I'm trying to find. The angle of the side I'm trying to find is 170. So that means that X will actually be the square root of all of this. And so if we do the square root of all of this, we should end up with square root of this guy, of this guy, this guy, this guy, and this guy. And if we check our answer, it should be 14.973, 14.97364, 7364. If you want to do significant figures, you can count 1, 2, 3. Do you round it up or keep it the same? You round it up, which would actually end up as simply 15.0. So, kilometers. If we look at the answer key over here, it says a method point for just trying to use the cosine rule. So notice how important the method, the procedures we try to employ are. See? And so just having this method clearly, just showing that you're attempting it, the IB already gives you a point. And yeah, getting the right answer, the 15, there you go. See? All right, excellent, nice. Some of you might have plugged in just as I did and you got the wrong answer. And you're saying, what the heck is my calculator flawed? Did it get hacked? What you might have to do is click mode and make sure you have this thing on degree. If you have it on radian, which is another way to handle like sine, cosine, and tangent, your answer will be different. Yeah, so that's pretty annoying, but it can happen. Make sure you have it in degrees, so that when you plug in, you get the answer that we are expecting. Yeah, that would be for part A double I. Then for part A triple I, we have that the bearing Tiki must use to travel directly. Oh, sorry. We have to discover the bearing that Tiki must use to travel directly from point D to point C. So notice, from point D to point C. So from D to C. And so from D, that means here, let's recall, for using a bearing, what's your first step? Your first step is that you draw a line all the way north. That is your first step. And so we draw the line that goes north in order to visualize this a little bit better. And we are going from D to C. So from D to C would be this entire angle here. This entire angle here is what we have to discover. And yeah, that's pretty much it. Yeah, so we need to find that bearing, right? So from D to C means this bearing that is entirely here. And the first thing we can attempt to point out, okay, is that this bearing is composed by two things. The first thing is the 90 degrees that is very heavily implied here because of the straight line. So because of this straight line, there are 90 degrees there. And then the remaining degrees is right here, which is the same degrees actually that we have there. And so for the bearing on part A, we can do 90 plus this guy here that I'm going to call y. So 90 plus this y degrees will give us the bearing we're looking for. So notice 90 degrees because of this part here. And then this little itty bitty thing is going to be this y degrees of this triangle. Now, what do you know of this triangle? This triangle up until now, we just discovered what x is, which we left it as 15. But I'm going to express the entire number. So the entire number is 14.97364. That is the DC. Now, stick to your procedures. In this step, what are you trying to do? You're just trying to discover an angle or a side, in this case an angle, within a triangle. And if you're trying to discover a side or an angle, in this case an angle, first try sine rule. So now we will be trying sine rule, which goes like this. You have A divided sine A, and you have B divided sine B, which is the same as saying side 1 divided by sine angle 1 equals side B divided by sine angle B, or angle 2, whatever. You know what I mean. See? So in this case, the question arises, do we have what we call a pair? In this case, we do. We do have a side associated to an angle. We have the 170 degrees associated to 14.97364. And so now you're going to understand what I mean by having a pair makes this so much easier, because plugging in to this formula here, aquí, okay, well, how it ends up like using that pair is 14.97364 divided by sine of 170 has to equal, well, the thing we're trying to find. The thing we're trying to find is this y degrees here, and this y degrees here is associated to this 13. It is associated to this 13 because it's on the other end, ¿cierto? And so that means we can express 13 for the respective side divided by sine of what we will be calling y. And so from here, if you want to discover what y is, what I like to do is first cross multiply. This is pretty common. We have two fractions equaling each other. So if you cross multiply, you would do sine y times the 14 equaling the 13 times sine 170. And so from here, you can end up with sine y equaling the 13 times the sine 170 divided by 14.97364. Now, most people reach this step and they can't finish, which is actually really unfortunate because they're one step away, but there's key concepts that they're missing in order to be able to solve this. Think about it this way. You have y inside, and you need to discover what y is, right? So you need to get y alone. So what the heck is the opposite of sine? Because the thing that's affecting y is sine, ¿cierto? Now let me go back a little bit in time, yeah? Let's say you have something like 2x equals 4, and I tell you solve for x, and you tell me, duh, x equals 2. Ahora, ¿por qué? Why does x equals 2? X equals 2 because you had 2x equals 4. 2 times x equals 4, and you did the inverse operation, which is divide, in order to discover that x equals 2. So whenever you want to get rid of whatever is affecting your variable, you always do the opposite. You do the what we call inverse operation, the inverse function. So if sine is affecting our y, you got to do sine inverse, the inverse operation, onto our y. And notice you got to do it to both ways. I mean, to both things. So that means you end up with sine inverse of this whole thing. See? And so notice that sine inverse, what it's going to do is that it makes this get rid with this. So you end up with y equals sine inverse of our entire fraction. Así que over here, we can do sine inverse, pressing the blue button and then sine to hit that sine inverse. And because we're going to be plugging in a fraction, I suggest alpha y equals, press the first one. So here we have 13 times sine 170. And then on the bottom, we have that 14 point blah, 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 0.97364,362. And that is what gives us 8.67097. So our angle is 8.67097, 1 with a bunch of 4s. If you think about significant figures, you count 1, 2, 3. Do you round it up or keep it the same? You keep it the same, so you can't leave it as 8.67 degrees. And so this itty bitty angle here is 8.67. And as we said earlier, our bearing is the 90 degrees plus that itty bitty thing. So because y is 8.67, we can leave our angle, the bearing that Tiki must use to travel from point D to C, which is this entire thing in light blue, as 90 plus y, so it's going to be 98.67 degrees, which is right here. 98.6.7, well, there's the 67, ¿cierto? Degrees, 67. and as you can see, sine rule or cosine rule works here. I can't insist on this enough. The IB is fascinated with us understanding the formula booklet, especially the sine rule and the cosine rule. So that would be for part A, a pretty long part A, but hey, it is worth 7 points. It was worth our time and effort. So good job. Our good old friend Tiki, although she spends a lot of time in the high ocean sailing a boat in the ocean, tends to do a lot of navigational errors. Now, it's probably pretty hard, I'm not gonna lie, but now there's another navigational error in the second part of the trip where Tiki arrives at point E instead of point C. And once again, point E is 2 kilometers, ojo, is 2 kilometers due west of point C, which is what I just wrote here. And so for part B, we need to write down the distance between point D and E and to justify our answer. So it's the distance between this guy and this guy. And so from here, that is interesting to say the least. All right, yeah. One argument you can do here, okay, is the following. It's very visually appealing, which is kind of nice. You can think about it this way. Initially, Tiki was saying, I will go to B, and then I will go to C, 13 kilometers. But Tiki got sidetracked exactly 2 kilometers to the west. And then upon arrival, those same 2 kilometers were still consistent. And so if the same 2 kilometers were still consistent, she still traveled 13 kilometers. If upon arrival, it would have been, I don't know, 3 instead of 2, then yeah, she would be a little farther off. And instead of 13, it would be different. But because she's still off by 2, that means she was consistent in her distance. And because it's, again, perfectly west, perfectly due west, then that's another argument for this being perfectly, like, she traveled exactly 13. So in this case, for part B, we would have to express 13 kilometers because navigational, or because, I mean, what I would do is because between DB and EC, both are due west 2 kilometers exactly. So 13 kilometers must have been traveled for this to be consistent. And so lo and behold, here you say the distance between point D and E is 13 kilometers, and part of your argument is that they make a parallelogram, or what I mentioned just now is that DB and EC are parallel and equal in length. And so yeah, I guess you could end up doing another triangle to discover the length of DE. But in this case, because it said justify your answer, for me it was a hint that there might be a quicker way out. And in this case, there was. And also because it's worth 2 points. Yeah, ladies and gentlemen, that would have to be for part B. Number 13, not exactly friendly, but very common for the AISL test. Bearing will appear, if not in paper 1, it will in paper 2. As you can learn it, love it, it is coming. I hope it helped, and that would be paper 1.